guest gathering and extend a warm and hearty welcome to the chief guest, President of Institution of Business India, and all of you to this IEI technical webinar on advances in design and manufacture of plastic injection molds. Today, I am very happy to be associated with this memorable virtual event. I am glad to inform that the Institution of Business India is the largest multidisciplinary professional body by encompassing 50 with about 8 lakh membership and gives engineers a global platform for sharing professional interest and information. The Institution of Engineers was established in 1920 with its headquarters at Calcutta and incorporated in 1935 by Royal Charter. It is the only professional body in India accorded this honor and serving the engineering fraternity for more than a century. Today, the quest for professional excellence has given it a place of pride in almost every prestigious and relevant organization across the globe. It provides a vast array of technical, professional, and supporting services to the government, industry, academia, and the engineering fraternity, operating through its 125 centers located across the country and 6 overseas charters. Besides, Institution of Business India has bilateral agreements with about 31 international bodies and membership of another 8 international bodies of the developed nations across the globe. I am glad to inform Telangana State Center is the legacy of erstwhile Nizam's Hyderabad State Center, formed on 20 August 2016 after bifurcation of Andhra Pradesh State Center. It has more than 9,276 corporate members on its rolls. It is one of the most active centers of the Institution of Business India, which engage successfully in translating the objectives and mission of the Institution of Business India into practice and back the best state center award for the year 18, 19 and 1920. The Telangana State Center has been playing a very important role in dissemination of information on engineering and contemporary technology, bringing industry, academia, experts, and professionals together. Webinar is on advances in design and manufacture of plastic injection molds. The injection molding is a manufacturing technology for the mass production of identical plastic parts with good tolerances. In injection molding, polymer granules are first melted and then injected under pressure into a mold. Plastic cools and solidifies. The materials used in injection molding are thermoplastic polymers that can be colored, filled with other additives. Almost every plastic part around was manufactured using molding, from car parts to electronic enclosures and to pitch appliances. Injection molding is so popular because of the dramatically low cost per unit manufacturing high volumes. Injection molding offers high repeatability and good design flexibility. The main restrictions on injection molding usually come down to economics and initial investment for the mold is required. Also, the turnaround time for design to production is very slow. On behalf of the Telangana State Center of IEI and on my own behalf, I once again extend a hearty welcome to the chief guest and the Honorable President of IEI and keynote speaker and chief guest Mr. A. Dayana Garu, Managing Director, Tool Crafts Private Limited, and the Chairman, Production Engineering Division Board, Dr. Satyanarayan Garu, FIE, and Chairman CATE, that is Committee for Advancement of Technology and Engineering, Dr. G. Ranganath Garu, FIE, and all of you for this important event. Thank you, one and all. Now I request Dr. S. Satyanarayan to address and give briefing about this technical webinar. So, over to Dr. Satyanarayan Garu.
Thank you, Brahma Reddy. Thank you very much. Today's our very important guest, Sri Dayanand Reddy garu, Chief Guest and Keynote Speaker of today's event, and our Institution of Engineers All India President, Dr. H.O. Thackeray Saab, and Chairman, Dr. G. Ranganath garu, our State Center Chairman, Brahma Reddy garu, State Center Honorary Secretary Venkat Subbaya, and today's moderator and earlier Honorary Secretary of Institution of Engineers, Dr. G. Chandramohan Reddy garu, panelists, today's speakers, Engineer N. Suresh Kumar, DGM, Paul Ritvik, Assistant Manager, and A. Fanindra of Vasantha Tool Crafts Private Limited, my colleagues from Institution of Engineers, State Committee members, and all other participants. Good afternoon to every one of you. It gives me an immense pleasure to participate in this webinar, Advances in Plastic Injection Mold Die Design and Manufacture, organized by the Telangana State Center of the Institution of Engineers. Our dynamic and very vibrant and very enthusiastic chairman, Brahma Reddy, started doing various activities, and this is one among many activities he has been organizing through Telangana State Center. I really, I'm very happy for the active role he has taken in organizing various activities of the Institution of Engineers through Telangana State Center. And one more thing is today's speakers are, I have seen the speakers of today's webinar, all are field engineers. All are working in, in the plastic industry. And as far as the company is concerned, I think Vasantha Tool Crafts is having, various organizations in Singapore, USA, and Germany also. They have their own units at other European countries. So with such, and they have, that what I was told is they are, all these operations are done by robotics. They use robotic arms for, particularly EDM, with various lot of complicated contours are to be machined in the plastic molds. This all the complicated contours, if you manually, if you do, each day requires about more than 100 and 150 cavities, and all the cavities manually, it's impossible to do it. I was told that they are using robots for replacing, inserting, these electrodes, changing the electrodes and again placing them in place. So that is really, and one more thing, they do double injection molding. That is two color injection molding and also two nozzle injection moldings. Such a great company has accepted. I think they are exporting about more than 300 crores worth of tools to Europe and America. Such a great company accepting to associate with our Telangana State Center and organizing this thing is really, wonderful thing. And this is what, what we need is this kind of, institute and industry interactions. Really thank you, sir, Dayanand Reddy sir, for giving us this opportunity. And every one of us know what is plastic. Without plastic, there is no life. Right from morning, when you wake up, toothbrush, you hold a toothbrush, and the toothbrush will have different shapes and different colors. All the things, various processes are there for making this. This is called multi-shot injection molding. So soft touch toothbrushes, handles, and multi-colored automotive tail light. Today, you see, if you are going in a traffic area, the tail lights, they are glittering like anything, and they will be disturbing. In fact, they will be falling in our eyes, and they will be disturbing our concentration. All these things are made through injection molding. There are various other processes, and even DVDs, our digital DVDs, CDs, something. All these things are, done by, I need not tell. And one more thing, today you see a lot of toys. Toys is playing a very important role, particularly, this toy hackathon has been organized by our Prime Minister recently, wherein I was a partner in conducting these various activities on toy. When I see the toy, a lot of mechanisms are there in the toy. Handles, that hands, articulating hands. It is not so easy to manufacture articulating hands in a toy, because it requires it should not touch, but at the same time it should be integral part of the toy. When you are able to move, if it's a solid plastic mold, it will not move. But these particular toys, they use dissimilar materials which will not have compatibility to each, and they will be articulating, and you can move the hands. And one more, winking eyes. One got down to that closing the eyes, winking eyes. All the various aspects are coming in plastic modes. I'm really very happy, that our Dayanand Reddy Saab has accepted to show his even videos, show his company and all the operations through videos. And today, plastics are very much useful. At the same time, they are very dangerous to the society. Today, particularly the single-use plastics, government is banning, which are less than 40 microns. So for that, probably, we all engineers have to come together, and there are already various methods have come with that biodegradable plastics and other things. But still, there are a lot of things are to be, invented, because the biodegradable plastics are used only for packaging industry today. When it comes to these buckets and plastic mugs and all our utensils, still biodegradable is not there. And there is one more area that R&D engineers have to concentrate and see that really biodegradable plastics are coming. And as far as the employability is connected, today plastic industry, particularly plastic molding industry, is providing employment to nearly about 4 million people. About 3,000 units are now exporting. There are a lot of things is there in plastics, and it's a very, very widely required field for all our, particularly to address the unemployability of our India. With this, few words, probably I don't want to take much of your time. Because the speakers are there, I don't want to talk on behalf of them. So with this, I once again thank particularly our Thakre Saab, President of Institution of Engineers, who has taken time to join this webinar, and our KATE chairman, and also our chairman, Sri Brahma Reddy Garu. And thank you very much. Over to Brahma Reddy.
Sir, thank you for the good words you have expressed about our center, and also about me, and the importance of this present webinar. Thank you, sir. Thank you for the address. May I request our Dr. G. Ranganath Garu, Chairman of KATE, kindly to address the today's webinar, sir.
President Garu, Thakre Saab, first President, give the chance for him.
Thank President, sir. I think I'll give big thanks to him at the last, because after his
First President, let him have. Way after the President.
I'm ready, provided you permit me. Okay, sir. Thank you. Chief guest and keynote speaker of the session, Dr. A. Dayanand Reddy ji, Managing Director, Vasantha Tool Crafts Private Limited, Hyderabad. Eminent panelist of the session, Mr. N. Suresh Kumar ji, DGM Design and Development, Vasantha Tool Crafts Private Limited. Mr. A. Fanindra, Senior Manager Design and Development, Vasantha Tools Crafts Private Limited. Mr. Paul Rithwik, Assistant Manager Design and Development, Vasantha Tool Crafts Private Limited. Moderator of the webinar, Dr. G. Chandramohan Reddy, Professor, Department of Mechanical Engineering, CBIT, Hyderabad. Dr. G. Ranganath G, Chairman, KATE. Dr. Sriram Satyanarayanan ji, Chairman, Production Engineering Division Board. Mr. Brahma Reddy ji, Chairman, Telangana State Center. Dr. G. Venkat Subbaya ji, Honorary Secretary, Telangana State Center. Council members, past Chairman and Honorary Secretaries of Telangana State Center. Telangana State Center committee members, members of media, and dear attendees. I consider it a great opportunity for all of us to be a part of this technical webinar on advances in design and manufacture of plastic injection molds being organized today by Telangana State Center under the aegis of Production Engineering Division Board. The Institution of Engineers India always puts sincere efforts to keep its members informed and abreast about the latest engineering and technological developments occurring in national and international arena through organizing technical events on a regular basis involving eminent professionals and practitioners. Over its last 100 years of existence, the institution has provided valuable solutions and policy inputs to the policymakers contributing to the national growth. For the last 2 years, with strictly imposed restriction due to pandemic, technical webinars are being conducted by the institution on contemporary topics regularly, which provides a virtual knowledge sharing platform for all members and the professional attached to the specific domain. The Institution of Engineers India has conducted approximately 30 technical webinars within the last 2 years with comprehensive coverage of various engineering topics, which have witnessed enthusiastic participation from the wide range of professionals. Today, Telangana State Center is organizing the webinar on the topic Advances in Design and Manufacturing of Plastic Injection Molds. Telangana State Center has always taken a lead in organizing the technical activities, and I must compliment its chairman and the team of Telangana State Center for their enthusiastic work. We all use plastics in our daily life, but seldom we think about the technology behind it. So it appears that this will be an interesting session for all of us. Plastic injection molding is the most well-known preferred process for manufacturing plastic parts. Most of the plastic products available today are produced by means of injection molding. With the use of multi-cavity injection mold, mass production of plastic components within optimum time frame is possible, which include electronic housings, containers, automotive interiors, etc. It is ideal for producing high volumes of plastic parts due to the fact that several parts can be produced in each cycle by using multi-cavity injection molds. Some advantages of injection molding are high tolerance precision, repeatability, wide range of material selection, low labor cost, minimal scrap losses, and little need to finish parts after molding. For injection molding, mostly polymers are used, including all thermoplastics such as nylon, polyethylene, and polystyrene, and different elastomers. Materials are chosen based on the strength and function required for the final part. But each material also has different parameters for molding that must be considered. Mixing the available materials with alloys or blends of previously developed materials enables product designers to choose from a wide range of materials to find the one which exactly has the right properties. To this aim, this webinar is being organized involving renowned experts from industry and academia to discuss and highlight the pertinent issues of plastic injection molding. Chairman, Production Engineering Division Board, Dr. Satyanarayana has already conveyed the wide range of products being manufactured and by the Vasantha Tool Craft Private Limited, which is a trend-setting pioneering industry in this field. The deliberation on these issues are expected to provide us more insights and leave us enriched. I hope the discussions during the webinar will encompass all facets of the subject holistically involving all stakeholders. We are all eager to hear from the experts on this emerging topic, and I hope everybody will get enlightened by their presentation. I wish this webinar all success. Thank you. Thank you.
Sir, thank you.
Thanks, sir, for your excellent and very informative and sir, we continue to follow our center with the same zeal and your leadership. We request Dr. Ranganath to kindly address this.
Respected President of II, Dr. Thakraji, respected Chief Minister of today's program, Sri Dayananda Reddy sir, eminent speakers from industries, Sri Suresh Kumar ji and Paul Ritik ji, the moderator for this wonderful program, Mr. Chandramohan ji, the hero of today's program, the chairman of Telangana State Center, good friend of me, Brahma Reddy ji, and beyond the subject expert, the chairman of Production Engineering Division Board, and good friend of me in the council from long years, Dr. Satyanarayana ji. And one more important council member is attending this program. Many of you not observed. Marine Division Board Chairman, Bhaskar Bhandarkar ji.
Not seen.
Is there in attendee? He is attending this program. I observed there. Then all the committee members of Telangana State Centers, all the participants, Kingshu from Technical Department of Headquarters, and all the participants. I am so happy to greet all of you. Good afternoon to all of you. Regarding today's program, beyond going to the today's program, my compliments to Telangana State Center. For past 1 decade, I am observing almost all activities at Telangana State Center. It is one of the state center, important state center in the country. Whenever there are connecting some programs, there is a good representation from industry, there is a good representation from the government organizations, and especially not only the attendees, the participants, speakers, contributors, sponsors, and so on. As far as my personal view is concerned, I am very proud to say it is one of the most active state center in the country. Of course, next to you, maybe Delhi and Punjab and Gujarat is following you. Though I am from Tamil Nadu State Center is there, Century Old State Center, were very difficult to bring this galaxy of speakers from different domains of industry and government sides. But it's happening from Telangana State Center. From almost all from past 10 years, I am observing cleanly. And they are bringing a very active and dynamic chairmen also. I am very happy. And coming to the Satnarayana ji is a production division chairman. Beyond that is the expert of the topic of production. So that's what he has given wonderfully. In addition to that, even our Thackeray ji is given a lot of information regarding plastic injection mold and its background. But when the good speakers are there, our chief guest, Dayanand Reddy, is a big expert in the same field, and two resource persons again, Suresh Kumar and Padrathik, they are from the same field, and our moderator is from mechanical department, Dr. Chandramohan ji. So all these speakers are going to speak. So let me not unnecessarily touch and disturb you. I know participants are going to get good benefit. But on this occasion, I want to appeal all the speakers, being all from the industry, I want to bring to your notice century-old institution of IEI. We already completed century-old and we already crossed. But till production department is having very small size in membership. And there is only one council member in production division. My humble appeal to all the speakers, including chairman of production division board, please see that you are going to increase the membership of production division. At least coming election, when 2025 comes, I want to see minimum 2 council members of production. Such a way, you should bring the members. And as far as my personal view is concerned, Hyderabad is the best place of industry when compared to Noida, when compared to Pune, and some of the centers in Tamil Nadu. Because including Hosur, there are good number of industries are there. There are good number of engineers are working in the same domain. But the only thing is we are supposed to approach them and convince them to become the forum of this IEI. And I want to bring to all notice, again, light membership fees is very, very nominal when compared to so many other professional bodies. IEI membership fees is very nominal. It's light membership fees, hardly 5,000 rupees per life. Please encourage, please educate, please bring good number of engineers. Chandramohan Reddy may be thinking that, sir, what about mechanical? There are big numbers, Chandramohan sir. But we want big numbers in production also. Because Satnarayana is there, and if he thinks he can bring a good number of people from Hyderabad, being there are a good number of industries. And today's topic is, as our president and Satnarayana both said, in the field of design and manufacturing, it is advances, particular domain of plastic injection mold. Very, very important domain. And its application is beyond one's imagination as today. I know speakers are going to endow this and all participants are going to get benefit out of it. With this, my biggest compliment to Telangana State Center Chairman, Honorary Secretary Venkat Subbaiah, and all other committee members. Then my compliments to Production Division Chairman, because Telangana State Center, whether offline program or online program, they are maintaining the same pitch and same frequency. That is appreciable thing. Generally, online program is maybe 1 or 2 speakers maximum, including chief guest. But in Telangana State Center, online or offline, good number of speakers, good number of participants, and good activities and effective programs. So my heartfelt appreciation to all of you, sir. With this, let me thank Brahma Reddy ji, who has given this wonderful opportunity for me. Let me thank Satnarayana ji, who made me to be with all of you. And let me thank our president, Thackeray ji, who made me to be with all of you as a CATE chairman. Thank you. Jai Hind.
Thank you, sir. Thank you, Ranganath sir, for the very good words about our center and all of us. And thank you. And you are a great inspiration for all of us also. So being a CATE chairman and also your earlier council member. Thank you, sir. May I request Dr. Chief Reddy Garu kindly to introduce to today's chief guest, Sri Dayanand Reddy Garu, and over to G. Chandramohan Reddy Garu. Hello.
Hello, Chandramohan Reddy garu.
Chandramohan Reddy sir, unmute your system. Sir Chandramohan.
Sir, Chandramohan Reddy garu, please unmute.
Your moderator.
Yes, sir. There was a technical glitch. I am back. I am just back to the program because there is a problem with the networking. Because I made all the arrangements, but still, when the problem comes, then only we will know. Yeah.
Okay, sir. It is over to you, sir, for introducing today's chief
Yes,
guest.
sir. Yes, sir. Yeah.
Right. Thank you, sir, and proceed.
Yes, yes.
Thank you.
Good afternoon, all of you. Sorry for the technical glitch on my side. Respected President of the Institution of Engineers, Dr. H.O. Thackeray, FIE, and then State Center's Chairman, Engineer B. Brahma Reddy, and today's chief guest, very, very important, Dayanand Reddy Garu, Managing Director, Vasantha Tool Crafts Private Limited, and our own institutions, Dr. Satyanarayana, Chairman, Production Engineering Division Board, and Dr. G. Ranganath, very dynamic Chairman, CATE, IEI, and State Center Committee members and all others, and including the Honorary Secretary and others present in the meeting. I extend a hearty and warm welcome to you on this occasion of the Institution of Engineers India holding a technical webinar on advances in design and manufacture of plastic injection molds in association with Vasantha Tool Crafts Private Limited. I consider it a great privilege for the opportunity to introduce today's chief guest, Sri A. Dayanand Reddy Garu, Managing Director, Vasantha Tool Crafts Private Limited. Actually, before I really go into the written matter, I would like to tell you, he graduated from KITS Warangal, the same institution from which I also graduated. He graduated in 1984 and I graduated in 1989. And he was very active. He is also the alumni president for some time. And since I am busy with the Institution of Engineers, I could not spend enough time for the kids alumni activities. That is the reason, sir. Now that I am a little bit available for kids alumni activities also hereafter. And that is one thing. Another thing is he holds post-graduation in tool design and manufacturing from Tool Room Training Center, TRTC, Indo-Danish Tool Room, New Delhi. He obtained this degree in the 86 and he obtained his BTech from KITS Warangal 84. And he worked with Siemens, Mumbai for a period of 1 year as tool room engineer from 1986 to 87. And as an entrepreneur, he has started Vasantha Tool Crafts Private Limited in the year 1989 for design and manufacturing of injection molds. See, the molds manufacture is really a difficult thing. I mean, he has really accepted the challenge and entered the field at an young age. And that's really appreciable. Without having much experience, he has accepted these challenges And when you accept the challenge and then try to work, definitely you will rise. That's how Vasantha Tool Crafts. Of course, this is synonymous with its growth is synonymous with technical and professional experience attained by our Dayananda Reddy Garu. Today, Vasantha Tool Crafts Private Limited has proved and established itself as a manufacturer of high quality precision molds. With 32 years of experience, Vasantha Tool Crafts has successfully designed and manufactured more than 3,000 precision injection molds for various applications like caps and closures for FMCG and pharmaceuticals, and high precision molds for medical, electrical switchgear, electronics, and writing instruments. These high cavity molds are with fully hot runner, including valve gates, by injection technology, stack molds, in mold closing for flip top caps, VTC with its highly qualified people and state of the art CNC machines, and CAD CAM workstations having latest CAD CAM and mold flow software, has emerged today as a favorite supplier for its high profile customer base in India and abroad. In order to test the molds for a trouble-free operation, started Mrs. Renika Plastic Crafts Private Limited in the year 2000. Established a second tool room, Unit 2, third tool room, Unit Balanagar, for manufacturing injection molds. Vasantha Tool Crafts has recently ventured into metal injection molding and also expanded its plastic injection molding operations. And of course, Mr. Dayananda Reddy Garu is adjudged as, as Best Young Entrepreneur in the year 1999 and was awarded State Youth Award by the Government of Andhra Pradesh. Awarded as Outstanding New Generation Entrepreneur by Indian Plastics Institute, Mumbai in the year 2013. Vasantha Tool Crafts is only the company in India has achieved the milestones in designing and manufacturing bicolor injection molds in the year 2010, rotary bicolor injection molds in the year 2013, cube bicolor injection molds in the year 2014, stack molds in the year 2012. So with this introduction to the company and to its managing director, we extend a hearty and warm welcome to you, sir, for this program. Now it is over to the chairman.
Thank you, sir. Thank you, Visi. May I request our today's chief guest, Mr. A. Dayananda Reddy Garu, Managing Director, Vasantha Tool Crafts Private Limited, kindly to address the today's virtual gathering, sir. Thank you, sir.
Thank you, sirs. Am I audible?
Yes, sir. Very much.
Yes, sir. You are audible, sir.
So, Chandramohan Reddy Garu, thanks for the long introduction. But of course, now we have noted that you want to contribute to the alumni of KITS, so which we are happy to note that. In fact, we also have our Suresh Kumar is also from KITS.
Okay.
So
Okay.
we have a big team of KITS people in and around, even in Hyderabad also. I know Mr. Ravindra Reddy of CBIT, but I didn't know that you are there and who is a KITSian.
Yeah.
So
Yes.
yeah, anyway, nice meeting you through this program. And coming to the today's topic says, good afternoon, everybody. Dr. Thakreji, President IEI, and B. Brahma Reddy Garu, Chairman, Telangana State Center IEI, Dr. Satyanarayana Garu, FIE Chairman, Production Engineering Division Board IEI, Dr. G. Ranganath Garu, Chairman, KATE IEI, and Chandramohan Reddy Garu, Professor, Department of Mechanical Engineering, CBIT Hyderabad, Vasantha's senior staff, ladies and gentlemen from participant side. Good afternoon, everybody, once again. First of all, we thank the organizing committee or the governing council of IEI for giving us this opportunity to showcase our strengths and also to talk about plastics in general and the advances in the mold making and manufacturing of plastic injection molds, etc. So let me switch over to a small PPT. I have a few PPTs.
Kingshak, please, screen sharing, please. Allow him screen sharing. Kingshak.
Yeah.
Headquarters, please allow him to screen sharing. Ramareddy garu, please see that the screen sharing is allowed.
Unpacking frame, sir.
WPS Mantra. Open. Are you able to see my screen, sir?
It's clear, sir.
Good, sir. Visible.
Yeah. Yes, sir. So once again, good afternoon, and sorry for the small technical issue. So any engineering or non-engineering product designer will have challenging time when he has to decide about the material for the parts or the sub-assemblies constituting the product which he designs. Today, leaving the one-time used plastic articles, other rigid plastic parts are playing an important role at the time of product design. Because plastics can offer a lot of advantages like ease of processing, multicolors, different surface finishes, bi or tri-injection, even it can be more than tri-injections, wide variety of polymers to choose based on the application, the end application, lightweight compared to the metals, good strength to weight ratio, ease of transport, shelf life, etc. So, and other aspect is sustainability. The problem what we have is the mechanism of disposal. This is especially in the developing countries or the third world countries. If we can have a proper legislation for the disposal mechanism, plastics can be the best material for any product designer to choose. Another solution for sustainability can be biodegradable plastics, wherein a lot of research is going on, and already some people have started using these plastics on a small scale basis. So having said all this, rigid plastic parts have become very important, and also the manufacturability or the method of manufacturing and its related tooling. So this is where Vasantha comes into picture as a mold maker and brings me to the today's topic of advances in design and manufacture of plastic injection molds. Though lots of new technologies were pursued in the West for many decades, such new technologies were adopted in India only since about 2 decades or so. So if I have to just a small introduction on Vasantha, established in the year 1989. And in fact, it's just a coincidence that on this Sunday, we are celebrating our annual day, 33rd annual day on 8th of this month. So, and any mold making activity or the plastic design activity itself starts with the product design, plastic product design. So the product designer would be doing FEM, finite element, FEA rather, for finite element analysis using different softwares and technologies. And DFM, design for manufacturability. So one can make a complex plastic part design, but if that part cannot be manufactured or cannot be molded, it will not be of any use. So what normally the mold designer or the designing department, mold design department does is the DFM. Once we receive the RFQ, request for quotation, we'll be doing design for manufacturability analysis, wherein we'll be seeing whether the part can be molded based on the thicknesses, based on the undercuts, based on the different side cores, etc. All that, the mechanisms which we'll be forced to use because of the product design, etc. And once we get the order, then the flow analysis will come into picture. In the flow analysis, we will be doing gate location, the flow front identification, shrinkage and warpage analysis, and many more, of course. We'll be seeing the air entrapments, etc., etc. And we can also find out the actual shrinkage. And even in the flow analysis today, there are lots of advances, which are some of those things would be discussed by our staff, senior staff members in their next sessions. So then comes mold design aspect. So this aspect would be explained again in detail in the next session, including different mechanisms and concepts, etc. So molders in India used cold runner concept for quite a long time. Slowly now they are graduating into semi and fully hot runner molds. Today we talk about hot halves, which means the entire fixed half of the mold, leaving the cavity plate, is made by the hot runner supplier, so that his warranty and guarantee terms are enhanced or increased guarantees we have. So, and valve gates basically is used to have a neat gate finish, which again will be explained by my senior staff. And the P20 steel used to be the synonym with the steel for plastic molds. In fact, even today, some of the low-level molders would come to us, can you make a mold in P20 steel? But P20 steel is a very basic steel for the plastic molds. So that used to be the kind of a synonym with the steel for plastics long back. But today we have lots of high-end steels with high composition and expensive steels, like pre-hardened stainless steel for the mold base itself. We use stainless steel plates, which are pre-hardened and with high chromium content. And high chromium steels, which are hardenable, are used for core and cavity inserts. Again, these are very, like sometimes we go up to 18% chromium, and which are very expensive, something like 1,200 rupees per kg. So again, this would be explained in detail by our staff. So P20 is still used for core and cavity in the automotive sector. If you want to make, say, a bumper mold or say mold for a bumper, then you cannot harden that such a big size insert. So the insert itself would be a plate, the cavity plate or the core plate. And in such cases, P20 is widely used even today because the hardenable steels cannot be used. And the vacuum heat treatment, I'm just talking about basically the advances or the difference. If somebody talks about a mold made 20 years back or 10 years back and today, so those differences I'm talking. So because the topic says advances. So vacuum heat treatment has replaced the normal salt bath furnace to have less oxidation and the less distortion in the heat treatment process. Even the case hardening processes like nitriding, etc., are also performed in vacuum furnaces in place of regular salt bath furnaces. Lots of special coatings are pursued today to increase the life of the sliding parts, thus increasing the overall mold life. When the life of the sliding parts goes up, the life of the mold also goes up. Coatings also help in easing the release of the part. Some of the plastics are such, they catch onto the core insert, and which calls for lots of ejection force. So these coatings would help us in reducing the releasing force or the catching force. So, and we also have today beryllium copper, which is a fast conductor. Copper itself is a high conductor of heat, but then by mixing with or by alloying with beryllium, it attains the hardness, which is at 40 HRC. The commercial grades available today in the market are at 40 HRC, which is being used to reduce the cycle time due to its high thermal conductivity, and also without compromising on the hardness, because 40 HRC for some of the molds, say medium life molds or low life molds, it's good enough. So thus the life of the mold is not compromised because the beryllium copper available today is at 40 HRC. And even beryllium copper cores can also be coated with the special coatings. So again, to increase the surface hardness and also to increase the ease of release of the plastic part. So 3D printing for having conformal cooling in inserts. If you want to have conformal, normally what happens is in any insert, in any plastic mold, you simply drill some straight holes or angular holes for sending the water inside, because you need to cool the plastic material, which gets injected at about, say, approximately 250 degrees. So we need to cool that part. So yeah. So sorry, now we are coming to 3D printing, conformal cooling. So when you want to cool the plastic part evenly, or even when you want to cool it in a shorter time, if you can take the water close to the surface of the plastic part, and not only close, if it can follow the profile of the plastic part, that would give you maximum cooling, or say theoretically highest cooling. So in a normal case, that would not have been possible. So today we have a technology called conformal cooling. That is again where we generate the core inserts or the cavity inserts using metal 3D printing. In fact, we have this equipment in-house in Vasantha for past 7 years. We use this technology. And yeah. So what happens in 3D printing is layer by layer, you deposit a special steel powder. Powder size would be 20 microns, and the layer thickness would be 40 microns. Of course, my next speakers would be explaining you in detail. So once you select the steels, etc., once you decide on the treatment processes and even on the conformal cooling, next stage would be the manufacture of the mold. So today we have advanced hard mills, means normally all our molds are hardened. In fact, we say class 101 molds, which means all our inserts needs to be. When I say inserts, again, some of you may not be aware, but people from the field would be aware. When we make high cavity mold, each cavity or two cavities will have one insert. So those small parts are called inserts, especially for high cavity molds for smaller parts. So these inserts need to be in hardened condition, which are at 50 HRC. The class 101 molds itself means, the classification itself means that inserts needs to be hardened to 52 HRC. And these got to be at least H13 hot die steel, or the high chromium steels like Stavax and Mirax. These are the brand names from Udehome. And then the mold base needs to be from pre-hardened stainless steel mold base. So these kind of molds, when you want to make, inserts are hard. So after the heat treatment, if you want to use the normal CNC mills, they will not be working. Means they will not be working means the surface finish would be very rough. The accuracies will not be enough. So when you have high precision hard mills, these mills are like, the concept is you cut the steel at high feed and high speed, but very less depth of cut. So when the depth of cut itself is less, you'll have very less surface finish variation. In fact, often we use 0.05 depth of cut, and for the finish cuts, in fact, we even give 5 microns, 10 microns, and 15 microns. So when you are running at such a depth of cuts, your variation, the surface finish variation cannot be more than the depth of cut. So, but here what you are using is the high speed of the spindle and high feed of the table. So it would be a kind of, the terminology itself is called high speed milling. So, and it would be faster, though we are using less depth of cut, since we are moving the table at high feeds, it would be a fast operation. And once you do the hard milling, there'll be a lot of areas where cutters cannot reach, cutters cannot mill. Even in the mills we use today nowadays 0.5 mm cutter. Sometimes for the graphite we also use 0.2 mm cutters. But there will be many areas where cutters cannot mill the hardened inserts, or cutters cannot reach certain depths, etc., where you need to do EDM or the spark erosion. And we use lots of EDMs. In fact, in any mold making process, the EDMs are the deciding factors, because these are the slow operations. Though today we have advanced machines which are much faster compared to what it used to be earlier, but even then, EDM is the one which decides your delivery schedule. It's something like that. In Vasantha, we have more than 20, close to maybe 30 machines we have, but even then sometimes we face problem. And then comes your wire EDMs. There are certain areas, again, EDM and hard mill will not be enough. You need to do wire EDMing, even for the electrodes, etc. We have all advanced wire EDMs here. And even in the market, today you have, which can give you easily 5 to 10 microns of accuracies. And CAM software, of course, here we use Mastercam, but there are lots of advanced softwares for CAM. So, and in our case, most of these design workstations are linked, networked through the server and through Windchill, networked into the machine shop, and wherein they take the data and then they generate toolpath or the CAM program using the CAM software. We also have robotic cells, this kind of machines. Now, whatever I mentioned, hard mills and EDMs and wire EDMs, these are housed in a robotic cell, means there'll be a linear robotic electromechanical robot would be moving on a linear track. The job of the robot is just to load and unload the jobs and load and unload the electrodes on EDM machines. Wire EDMs cannot be put in a robotic cell for different reasons, but there is a small amount of automation there also nowadays in the market. And we also have little bit of automation on wire EDMs. But whatever robotic cell I am talking is for graphite milling, or for the electrode milling, and also the hard milling and the EDM process. So normally what happens is, once you make the electrode, you need to find out the edge finding or the point which you want to program for. You need to know where that lies with respect to the holder. So to do that we call it as edge finding or the job referencing. So that itself, sometimes if it is in a manual mode, operator would take a lot of time. And whereas in robotic cell, all this is pre-programmed. This is done offline, like we don't have to disturb the machine. So when the electrode change takes place, within a minute or within 2 minutes, the operation starts. If the same thing is done manually, it may take 5 minutes, 10 minutes, or even 15 minutes, nobody knows. So today we use 2 robotic cells in Balanaga plant and 1 robotic cell in GD Metal plant. And we also have another robotic cell in Austrian operations. So special operations like thread grinding, gear grinding, these also we use, but this we don't have in-house. We get them done outside. And lots of advanced bought-out items like different types of gauges, advanced bearings, LM guideways, servo-electric technologies. Servo-electric technologies we use for the side core movements, for the unscrewing. If I have to rotate any threaded core, which is having thread core, which is used for a component, for the plastic component having threads, I need to rotate the threaded core. So for doing that, normally we used to use hydro motor in the very beginning. Then later on we switched over to racks and hydraulic cylinders. Then today we use same racks, but with an additional attachment, and the cylinder gets replaced with a servo motor and a ball screw. So, and such operations can also be used for side core movement. Sometimes you may have deep side core. So wherein if movements are say more than 50 mm or 60 mm, we can use even servo electric technologies. So the advantage of servo electro technologies is you can do a lot of operations parallelly. Means before even the mold opens, you can do certain operations, or while the mold opens, you can do certain operations. most of our molds keep running at about 10 to 12 seconds. And even if you save 1 second or 2 seconds, it would constitute something like 10%, 20%, which is a big amount for the molder. So molders always look for, whoever can afford, they always look for such high-end solutions which are being offered by Vasantha. So, and then after machining all this, after having brought all this, all the parts would go into the assembly area. And before going there, we would be, all the inserts and the plates would go through.
The slides are not moving. Somebody is, commenting in the question. Slides are not moving. Slides is not happening.
No, no, sir. Yeah, I'm in another few minutes it will do. I'll do that. So.
Okay, sir. Okay.
So all these inserts and plates would be going through the metrology departments, wherein we have advanced CMMs from Carl Zeiss, and these CMMs include both the contact type and non-contact type. Contact, when I say contact, it's touch probe, and non-contact is cameras. Like on one machine, we have a probe, but where probe cannot reach, it uses white laser camera and infrared camera. So to find out the XYZ coordinates. So then after doing all this, when the mold gets assembled, it will get into a testing area where we have advanced injection molding machines from different brands, and most of the equipment is imported from Germany and Japan. And even some of these machines are all electric. And we have like rotary tables, and again, servo technologies I've just mentioned, but we use in-mold closing technologies wherever. I'll be coming in the next slide perhaps, that we specialize again. Today, 80% of our capacities are used for making the molds for closures, specialty closures. So most of these Dow and L-Vive, L-Save, fructase, earlier fructase, and all these, say, Clinic Plus, when you see all these shampoos, you have closure on top of the bottle. So these closures are having flip to close the orifice or to close the dispensing hole. So these flips are molded in these closures are molded in open condition, means flip is in open condition. And in the mold itself, we close that flip and then eject the component. So that's what, I mean, now in fact, my next speakers would also be mentioning the FTC and IMC. IMC means in mold closing, which means that that flip will be closed inside the mold before the ejection of the part. So we are avoiding a second operation, which needs to be done by the molder, So that's getting avoided. So you have a product which can be directly sent to his customer. So in the testing area, we also use scientific injection molding technologies. Our teams have been trained by a team from UK. They are very specialists in this technology. So means they tell you how to scientifically do a mold testing. And then we also calculate the statistical data, which is CPC PK values, using Minitab software. We have a software called Minitab, and nowadays there's one more software also available to do this CPC PK values. So coming to another main topic of what areas Vasantha specializes in mold making, we are good at making molds for switchgear industry, because as Mr. Chandramohan Garu mentioned, I was with Siemens Mumbai for my first year of career. And in those days, early days, we only know switchgear. So we used to make molds for Siemens, L&T, which is last name Tubro, and Schneider, Legrand, etc. But after those initial years, then when we got into FMCG in a big way, so today our capacities, 80% of our capacities are used for FMCG segment, and balance 20% like switchgear, medical, and pharma. So, and when we say again FMCG segment, we specialize in unscrewing molds, stack molds. Stack molds means there can be 2 stack, and of course 3 stacks would be very complex and expensive. But when I say 2 stack mold, from 2 surfaces or from 2 planes, you will be getting the components. In a normal way, if you say, for example, 8 cavity mold, and if it's an 8x8 stack mold, which means from 2 planes, you will get, from 1 plane, you will get 8 components, and from another plane, you will get 8 components. So you'll get 16 components. Your mold surface area doesn't change, but your mold thickness changes. So that is why the injection molding size may not change much, but you will have double the production. Molds are expensive, molds are complex. And as I just mentioned, we also specialize in IMC molds for flip-top closures, in-mold closing. And of late, for past 10 years, from 2010, I would say, not 10 years, 12 years almost, we very much specialize in bicolor molds, means molds for bicolored components. As I mentioned just now, Dove, Elvive, Elsive, Fructis, and Clinic. There are many more, in fact. Even some of the Himalaya components, you see two-colored components. Most of the two-colored components which you see in the market are manufactured by using the molds made by Vasantha. In fact, we can proudly say maybe 80%, I would say definitely. And these bicolored components are the molds that can be manufactured by using three technologies. One is core back, and the other one is rotary and the cube. So all these technologies will be explained in detail again by our teams. And we are one of the very few global cube mold makers. Means cube. I'll be showing you a video of a cube, so you may understand. And then when it comes to the process or the technology, one of our speakers would be explaining that. So, and we also use at Vasantha, we also use a lot of additional infrastructure to test these molds, like rotary tables. When you say the second category is rotary, I mentioned as rotary. So to run a rotary mold, you need a rotary table mounted onto the injection molding machine. And to do all this bicolor, tricolor molding, you also need to have a secondary injection unit or tri-shell injection unit, means you need to have additional injection units. Sometimes, in fact, we have done some molds like that. The second color itself gets injected at two places, though the injection is taking place totally at three places, means the primary color, second color can get injected at two places, but it's called tri-injection, but two colors. So, and to do all this, we have lots of auxiliary equipment available in-house, and injection molding machines with longer daylight, etc. All that. And as Chandramohan Reddy garu mentioned in his introduction, that we have also started MIM, metal injection molding activity, about 4 years back in a small way. We have just two furnaces of each, two injection molding, two debinding furnace, and two sintering furnaces. Here what happens is the fine metal powders along with the binder, and initially these are granulated first. They are made into granule kind of a structure. Then these granules, which is a metal powder along with the binders, they are injected into a mold. Mold will be exactly similar to injection molding. Basically, what we are talking about when it is said MIM, it is the plastic injection molding and some of the powder metallurgy technology. So these powders get injected into an injection mold, and the part which comes out, we call it as a green part. It is a metal powders bounded by a binder. So then we put them into a debinding furnace where we take out that chemical, synthetic chemical, by heating it up to 200 to 250 degrees. Then you have a honeycomb kind of a structure. The first piece is called green piece. The second piece is called brown piece. So it can be a little fragile, but it won't fall down. Then this brown piece is put into a sintering furnace where we heat it up to almost 1200 degrees based on the steel composition. And these products shrink almost 20-22%. In plastics, we talk about 0.5 to 1%, 1.5%, whereas in MIM, they shrink about 20, 22, 23% by size. So then finally, it would be something like 99% solid density. And this technology is very good for if you want to have, say, for example, you want to make 50,000 pieces per day, a small metal part. Having little intricate shapes and requiring good accuracies. So there's no other method other than this MIM, because you can't be cutting steel and then you can't be machining those parts, which will be very expensive. So for any medium size or high batch productions of any small steel parts, having requirement of good accuracies, etc., this is the technology. So all these technologies would be explained in detail in the next three sessions. And at the end, I would like to show you a video of a cube mold for a shaver running at 7.5 seconds cycle time. This is a 32 cavity mold. The photograph is seen on the screen. So this mold is running in Dubai for the past 5 years, and our tool maker or for the assistants, our serviceman went only once over there in the past 5 years, apart from commissioning in the beginning of the 5 years. And today, Vasantha exports close to 60% of the annual turnover by value. And our molds run almost in 40 countries. And we also have a greenfield factory in Austria, about 200 kilometers from Vienna. So, and I'll be showing you 3 videos, one for the cube mold, another one facilities showing, another video showing Vasantha's facilities in Hyderabad. And the other one is, we call it as VTW, the Austrian plant. So video showing the facilities of VTW.
The cursor पे लगे cursor So basically here what happens is on the right side, you have a primary injection. That is, we call it as a first phase. And the black one, which you are seeing in front of the operator, that's a cooling phase, and it is the second phase. In the next rotation, the second phase goes to the third phase, wherein it receives the second material, blue material. And in the next rotation, the third phase will be at the fourth phase, where the ejection takes place. Because parallelly you are doing many operations, you are injecting first color, you are injecting second color, you are cooling the part, you are ejecting the part. So theoretically, cycle time should be at least 50%, but yes, it almost reduces by almost 30 to 40%. And a rotary mold for the same article, we used to run at about 12.7 seconds, and this 32 cavity mold runs at about 7.5 seconds. ऑडियो नहीं आया बोलता है ऑडियो ऑडियो
Sir, is there any audio support for this?
Yeah, I think there's something wrong, sir. Audio you are not getting, I believe. I was not knowing this.
Yeah.
One second.
Yeah, actually, when you share, you can share not just the PPT. Below, there is a multimedia sharing is also there that you may press.
One second.
Yeah.
Then if chairman permits, I would like to run the videos again, 2 videos at least.
I think your panelist will be again showing, no? You can leave it to them, they will.
No, they may not show this. These things they may not show. We are already running late, actually. Yeah. क्या हो गया? Are you able to hear, sir, now?
Yes, sir. No audio, sir. But,
No audio?
no audio.
No.
From video there.
Do you have the audio now? No.
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 Okay. Then
maybe okay, I'll ask somebody to play it afterwards. But at least you can see the video now. Then we'll close
Yeah.
it.
Yeah, okay.
Oh. Again. So some of the decision makers and from the participants, even otherwise also any decision maker, I request on behalf of the tooling community of India, please do not import the molds and make them in India and help in achieving the PM Modi's slogan that Make in India concept. And I thank you with this for your patience and sorry for overshooting the time. And once again, I thank the IEI Governing Council for giving me this opportunity. Thank you, sir. And Chairman Garu, I'll be logging out, but my panelists will be there.
Thank you, sir. Thank you, Dr. A. Dayananda Reddy Garu.
Thank you.
For your,
Yeah.
sorry.
Yeah. Dr. Dayananda Reddy Garu, thank you very much. Actually, first time I met you in 2006 in Kids Warangal alumni meet. Afterwards, after long gap, we are seeing here.
Right,
So,
right.
2006 to 8, I was the Honorary Secretary of the Institution of Engineers, and then moved to MGIT as its principal from 2009 to 18. That's why there is a gap.
Right.
So, I was into administration and
Yeah,
could
yeah.
not.
In fact,
get it.
recently we did speak about you at one of the events.
Ah,
So,
yeah,
because
yeah.
nowadays younger team is taking care of kids alumni now. So
Okay.
we did speak about you. Yeah, yeah.
Yeah. Okay, sir. Definitely, I wish to visit your company now because after
Please,
seeing all the business.
most
Yeah.
welcome any point of time.
Yes,
So
yes, sir.
thank you.
Thank you, sir.
Thank you, sir, for excellent presentation and very practical on-site display and video of Vasantha Toolcrafts, and also aligning with the Make in India concept of our government of India. Thank you, sir.
Thank you, sir.
Now,
Thank you,
may I
sir.
request, sir, thank you, sir. May I request Dr. G. Chandramohan Reddy Garu kindly to introduce the panelists and also continue the program. Thank you, sir. Over to Dr. G. Chandramohan Reddy.
Yeah. Good afternoon, all of you. Once again, now it's my turn to, after listening to the overview of plastic dye industry by Mr. A. Dayanand Reddy Garu, Managing Director. Now we have three practical men. I mean, we are actually handling the machines at the shop floor all the time. Of course, their team is led by Sri N. Suresh Kumar Garu, DGM Design and Development, who is going to speak on quality systems for dye mold industry. And we have their senior manager, Mr. T. Phanindra, Design and Development, again, design techniques and use of advanced software for mold industry. And of course, one more young and dynamic person from Vasantha Toolcrafts, Mr. Paul Ritwik, Assistant Manager, who is also in the area of design and development, who is going to speak on advances in mold materials, plastics, fabrication, heat treatment, and surface coatings. I may take 1 minute to introduce each of them. Of course, we have Mr. M. Suresh Kumar, who has graduation from Kids Warangal, Kakati University. So we both belong to same alma mater. He also passed out in 1986. He's senior to me by about 3 years. I think if he has not done ragging at that time, he still has the opportunity to rag me. So, and he's also done PG TDM, Tool Design and Manufacturing from TRTC Tool Room and Training Center, Delhi, in the year 1990. And since then, he has been working in the core. I mean, he holds the core professional experience in L&T switchgear unit, Mumbai 3 years in tool design and process planning, and Hyderabad Connectronics 2 years. BPL Engineering 9 years, and Gala Pressure Technology Mumbai for about 5 years. Vasantha Toolcrafts, I mean, for the last 12 years he is there. Totally 31 years of very rich experience. Field of expertise include high pressure press tools, design, manufacturing, maintenance, and production, plastic injection molds, design, manufacturing, and production, management representative in respect of ISO 2015. That's about Mr. N. Suresh Kumar, DGM. Sir, we extend a heart and warm welcome to this technical.
Thank you, sir. Thank you, Chandramohan Reddy garu. Thank you very much.
And then we have Mr. T. Phanindra, who is their senior manager, design and development. And he has BTech, he holds educational qualifications, BTech Mechanical Engineering from IASC deemed university, obtained degree in the year 2008. Post-diploma in plastic mold design in 2001, CPET Hyderabad, and one more degree CPET from DPMT, that is Diploma in Mold Technology, in the year 2000. And he has a total of 21 years experience in Vasantha Toolcraft. Field of expertise include high pressure injection molds, design, manufacturing, maintenance, and production. So I extend a hearty and welcome, Mr. T. Phanindra Garu.
Yeah, thank you, sir.
And then we have, of course, from younger team, Mr. Paul Ritwik, Assistant Manager, Design and Development. He is MTech CAD/CAM, Mechanical Engineering from DRK Hyderabad, JNTU Hyderabad University. He passed out in the year 2015. Then PG, DTD, and CC, that is from Tool Design CAD/CAM from IGTR, Indo-German Tool Room, Aurangabad, Maharashtra. This is an Indo-German government project. He obtained this degree in the year 2013. BTech Mechanical Engineering from JNTU University, Hyderabad in 2011. and he has a total of 9 years of experience in mold design and development from Vasantha Tool Crafts. And we extend a hearty and warm welcome to Mr. Paul Ritwik. So this
Thank
is,
you, sir.
with this
Thank
brief
you.
introduction of the panelists is over. Now it is over to the panelists. Now we will hear to them. Yeah, I think the order in which they will speak is as per the invitation. First, Mr. T. Fanindra will make a presentation on design techniques and the use of advanced software for mold industry, and then we will hear from Mr. Paul Ritwik, and then we will hear Sri N. Suresh Kumar Garu. Yeah, I think that is the order given in the invitation. It is up to them. Okay.
Yep. So thank you all, the IE Institute, for giving us an opportunity to showcase or present our industry, how we are proceeding, and what are the advancements we are doing in day to day. As every sector is nowadays going in advancement and improving their own organizations and giving the outputs in all areas. So I will directly jump into my presentation. So I welcome you all in design techniques and use of advanced softwares for the mold industry. So as my experience is from basic studies, like I have started my career with tool making institute from CPET, tool design, and I have completed my BTech. So after that, I am with Vasantha from past 21 years. So I started as a design engineer, and now I am at a senior manager cadre. So taking care of the design and development department. So here I will take you into the molds. Actually, what is an injection molds? So here I had explained, like, the injection mold is an assembly of parts within which contains an impression into which the plastic material is injected, cooled, and ejected. So we'll be pushing the plastic material into the mold, and we'll give some time to cool it down, and eject the component. So in other words, we can say injection mold is a tool which is used to produce the plastic parts. And as I mentioned, like impression. So impression is formed in two mold parts. One is the cavity, and other one is the core. So the cavity is the female portion of the mold, which gives the external part of the plastic part, and core which is the male portion of the mold, which gives the internal formation of the plastic part. So this is the basic construction or basic theory behind the plastic molds, from which we will be getting the plastic products. So this is the basic nomenclature where you can see the cavity area, which is the exterior part, and onto your right side it is core, which is on the inner part. It's the male portion of the component, and in the center you can see the plastic part, how it looks. And on the below image, you can see the material is injected from the machine nozzle, and the other part which is stays in the mold, it is called as sprue. And all this black surface is the impression area where we get the component. And this is about the injection molding machine. So these machines are used for producing the plastic parts. So here what we would be doing is we would be heating up the material. So on the below image, you can see there would be a hopper where we would be dropping a lot of polymer, which is in the granule stage, and dropped into the machine barrel. So here we had mentioned as the heaters. So which the heaters would heat up the barrel, and the granule material is being converted into the liquid stage or semi-liquid stage, and pushed into the mold to create the plastic component. So after pushing the plastic material, it takes some time for cooling it and ejecting the part. So onto your right side, we have some machines presented, injection molding machines. And here it is in the initial days, how we used to do. the design activities. On to your right side, you can see the drafter boards where the designers used those drafters in initial days for creating the mold designs, and they use different sort of pens or pencils in differentiating the lines, the border lines, the main surface lines, and use the calculators for measurements, and each and every part will be drawn manually on those boards in those days. Actually, even from my side, when I was in CPET learning the uh, training in the institute, we used to draw on the boards itself. And after completing the drawings, these tracing sheets will be taken and converted into blueprints, and those blueprints will be used for the manufacturing of the parts, which is being released for the manufacturing team. So based on those detailed drawings, they will start manufacturing the cutting the steels and making the core and cavity parts and other accessories inside on the mold. And nowadays it is like all the instead of drafter boards, we are using high-end workstations, advanced softwares for designing and drafting of the plastic components, mold assemblies, detailed parts, and material lists. So instead of manual handling all those activities, nowadays we are depending on the high-end workstations with the systems and the softwares. So these softwares will be used to reduce the errors and also reduce the time for completing the design activities. So by using the simulation softwares, we can predict the flow pattern, cycle time, issues like weld lines, air traps, warpage on the plastic part. So even before building the mold. So in this way, we can save time and money. So these, with the help of these softwares, we are going to get the cycle time prediction and all the issues what we are going to achieve or what we are going to face before building the mold. So we can get all the inputs from the software itself. So once we receive these inputs, we can modify on the mold before cutting the steels. So this way we can reduce a lot of time and reduce money. So here the different stages where we are going to use the softwares are being presented. Like here, first stage of the product is the product development, as my MD sir informed or explained in his presentation, like the stages. The stage one would be the product development of the plastic component. Then once the product is been designed, that would be placed into the simulation software to see the gate locations, fill patterns, and cycle times and any defects on it. So if there are any defects, then again we can go back to the product development and modify or tweak some areas in modifying the thicknesses or changing the gate locations. And at stage 3, it would be like a mold design. Once the product is frozen, that would be taken to a mold designer. He will be creating the mold designs and material lists through which the material can be bought out. And at stage 4, it is for the manufacturing. So in the design stage, we would be creating the core, cavity inserts, mold base plates, everything would be done in 3D package. And those 3D inserts or the 3D plates would be transferred to the manufacturing department through the LAN, and they can start generating the programs for cutting the steel. So here is the 3D modeling. You can see on the screen, we have some of the software mentioned in the screen. It is Creo, Unigraphics, SolidWorks, CATIA, and AutoCAD. So we can generate a 3D modeling of the plastic part, for which we are going to build the mold by using the above software. So there is a small video on the screen. So I think video is not playing. We need to upload this. So onto your right side, it is actually a 3D model what we have created using a Creo software. And these are the flow analysis softwares. It is MoldX 3D and MoldFlow from Autodesk. And both the softwares are used for plastic flow and cooling analysis. So these softwares will guide us in indicating the below points and predict the fill pattern, any issues before cutting the steel. So we can predict what is the best gate locations, fill pattern, effective cooling design, defects on the part, and multicolor, multi-gate, and multi-material. So before even go for any steel cuttings, we can do all these activities using the software. So this is one of the study where you can see 3 different gate locations on a particular part, how the polymer is going to flow. So this blue area is the gate location for number 1. So if I keep a gate on this portion, so how the polymer is going to flow and what are the defects we are going to come. So this study has been done. So, and second one would be at this area, the green area, the blue area actually. And on the third, it is onto your left side. So all these portions are being tried and we came out with one conclusion of going at the top area. So it is flowing uniformly and it is fusing at this area. So this is about the gate location from the simulation software. And I don't know why it is not playing. So this is another analysis software actually, fill analysis, what I try to present in. So for this, it is a cutlery tray. We are having some defects on flow pattern, like these 2 ends are to be the last fills. So we have worked on the wall thickness modification, then we could able to achieve the best fill pattern. And this is for cooling efficiency. So we have 2 different cooling designs for a particular part. At what temperature the material is been getting cooled. From the software, we can get the results. And as my MD sir has explained, like the conformal cooling. So onto your left side, this is a traditional cooling design, what we have designed. And we are at 24 seconds of the cycle time. Then we had developed a laser fused core and we ran the mold and we are at 17 seconds. So you can see the lot of cooling circuit design has been worked. So for this laser fused core insert, we have to depend on a special purpose machines which we are having in-house. So conformal core cooling has been worked out and you can see the case study on the screen. So there is a huge cycle time advantage has been given to the molder. And on this one is about the defects. What are the main defects we are going to get on a plastic part? So during flow, there would be some gases generated and these gases get trapped in between flow fronts, causing the air traps. So with the flow software, we can predict these air traps. These can be avoided by providing air vents, improving the flow, changing the gate positions. So these are the main areas what we need to look into to avoid the air traps on the product. And the second issue is about the weld lines. So this is like 2 opposite flow fronts meets each other. So there we would be seeing some sort of line or a mark on the product. So this also can be improved or avoided by changing the gate positions, improving the flow pattern, and sometimes it has by increasing the wall thickness or working on the wall thickness parameters, we can avoid these weld lines. And this is about the warpage. So this is a deformation formed on the plastic part due to a different wall thickness, improper cooling on the mold, wrong gate type and location. So if a particular part is been designed with an improper gate location, there is a chance that we can see a warpage effect on the product. You can see on the middle image where it is not touching to the floor. So only at the center portion, the component is touching and two ends are getting opened up. This is also a defect. And onto your right side, there is a tub with very thin wall section containers. So you can see a warpage effect on this larger size. And the fourth defect what I have identified was about the shrink marks. So this is formed due to the wall thickness variations on the component. This also can be predicted using the software. So you can see on the right side image where we can the color differences like the green, red color and the circular portions are a differential wall thickness. Like on the top face, we might be having a 1 mm thickness, and at these areas it would be a pillar formation, whereas the wall thickness has got increased, and due to this there would be some deformation or shrink marks on the product. So this is also one of the defect in the plastic parts. So coming to the mold design part, we had used Creo 7 and Unigraphics, SolidWorks and AutoCAD is also, all these are some of the softwares used for mold designs. So I'm onto the screen, you can see there are two halves. Generally we call them as moving half and moving side and fixed side. So onto the fixed side, we will be having the cavity area, and onto the moving side, it would be the component core areas, the interior part of the component, and there would be ejection system for ejecting the component. And onto the fixed side, it will be the exterior part and injection part. So from where the polymer will be pushed into the mold. So this is a video, actually 3D mold. We are unable to run the video files. I don't know. So this is about the manufacturing. Here also we are using Creo 7, where we can use the electrode extraction and generate the CRAM program. So smart electrode is also used for electrode extraction. So DelCam is for generating the tool path. Unigraphics NX is also the CAM for tool path generation. And CAD Micro is the software used for wire cut machines. So onto your right side, you can see this is a cavity block, which consists of two parts or two components. And for this, we have to use electrode. Onto your right side, it is an electrode for manufacturing or for making the cavity part in the cavity insert. And this is palleting concept, what we are using in house. So initially, the blocks will be placed on a pallet and would be straight away transferred into the software. And the robo will be picking up this pallet and placing into the milling machines and also EDM machines. So it would be program generated, and accordingly the pallets would be placed and machining will be taken up by the robot. Actually, I had another video wherein we can see a tool path generation, which we are unable to show you actually. And this is about the process of a mold. Depends on the following parameters. Designing process of a mold actually. So here it depends on the plastic part, the injection point location, and type of runner system. So regarding runner systems, we have three different options. One is the cold runner, and the other one is semi-hot runner, and the third one is the hot runner systems. I will go in deep in next slides. And the number 4 is about the part production requirement. So based on the part production requirements, the tool design also will be planned. So here on the screen, you can see the parts having interior threads or undercuts would have a different type of mold construction need to be designed. So for that, we use multi-stage ejection, collapsible core design, and the lifters. So here on the screen, you can see both the options of internal threads with two different components. So these internal threads are being released using a multi-stage ejection system, wherein we would be releasing the exterior part of the component and eject the component using the sleeve or snap core mechanisms. And here is another option of fine internal threads, where previous slide, these are threads which can be ejected forcibly. So there will not be any damage. If you can see on the screen, it's a completely rounded off thread, wherein it can be directly ejected from the mold. But in the next slide, what I mentioned is the fine internal threads. So here the thread profile is closer to the horizontal. So I cannot eject it forcibly. So we need to depend on unscrewing mechanisms. So for unscrewing designs, we have three different options. It is hydromotor. Second one is using hydraulic cylinder with rack and cam mechanism. And third part is using servo motor with lead screw system. So these are the three different images what I had pulled out. The first part was with the hydromotor with lot of gate trains running across the mold. But the power transmission will be transferred from the hydromotor, which would be then transferred till the threaded core for the unscrewing the component. And the second option was with hydraulic cylinder using rack and cam. So here we have only 4 racks of it, which is been connected with all these threaded cores. So when hydraulic cylinder pushes forward, the rack would be rotating the threaded core and converting that into unscrewing of the component, plastic component. And the third one is servo drive or servo motor. Instead of a hydraulic cylinder, we would be depending on a servo drive or servo motor for same purpose. Like racks would be, we have a lead screw connection with the servo motor, wherein the yellow color plate would be pushed forward and backward for unscrewing the threaded core. So these are the three options of unscrewing mechanism what we are using. And this is about the external threads. So for the same part, we have like internal thread is there and also the external threads are there. So for the external thread, we use the sliders mechanism, which has been operated using the finger cams. So even instead of finger cams, we can use the dogleg cams or the hydraulic cylinders. Such mechanisms can be used for releasing the external threads. Actually, this is also one of the video wherein we have a external threads and those slides are being operated using hydraulic cylinder, and there is a robo pickup for picking up the components. Instead of falling it down, the robo comes and picks up the samples. And this is about the internal undercuts. And here we are using the lifter mechanisms. So there would be lifter which is running at an angular surface and moving it inside. The undercut gets relieved while the plates are being pushed forward. And this is the other option of internal undercuts. It is a collapsible core design, which is more complex structure. Instead of using unscrewing, we can use this collapsible core concept. And this is about the flip-top closures. So it is a special category of closures wherein the molds is based on the size shape of both flip and base. And we design most of the molds with the in-mold closing system, as my MD sir has explained about such parts, construction of the mold. So here on the screen, you can see it's a 32 cavity mold, wherein we have a unit above the mold, which comes below the flip and it gets closed. The component is getting closed inside the mold itself and it gets ejected. So we ran these molds at 10 or 12 to 13 seconds in between. And this is other option of a bicolor concept with core back mechanism, wherein we have, this is a Navratna cap, which we had supplied to the customer. So we have this core, which is being moved forward and backward using a hydraulic cylinder within the mold. So initially, when we are filling the red color, this core would be pushed forward and avoids the flow of red color into the yellow area. So after filling the red, we will push back or pull back the core and start injecting the gold color. After filling the gold, we will open the mold and eject the component. And these are some of the options or different examples where the punch back concept has been used. So this is Dow, and this component is L'Oreal, and the bottom one is for Himalaya. And even on this red, green and red, this is also for the Himalaya. All these molds are being made using the punch back concept. So this is the rotary concept, wherein we have two different stations. Like in station one, we have one cavity, and at a different stage, we will have a second cavity to fill the first color above the second. So this is about the cold runner system. The plastic material will be injected from the mold through the nozzles into the mold and through the runner into the component area. So here we would be losing or wasting a lot of plastic material over this surface. So virgin material will be cannot be used at the second stage. And here it is a semi-hot runner, wherein the material will be injected into a hot runner system through the nozzle. And here on the bottom, you can see the cold runner system into the components. So here also we'd be losing some part of amount. Instead of the cold runner, where there is a huge wastage, here we can some part of the polymer can be saved with the semi-hot runner system. And this is a fully hot runner system, wherein the polymer would be directly pushed into the hot runner, nozzle, and the component. So here there will not be any plastic material is getting wasted. So virgin material will be straightly pushed into the component for every shot. And these are the molds which are used for high production required samples. So this is a stack mold, wherein we have two cavity halves, two core halves. So from these two phases, we would be getting the components. So all the other molds what I have presented is a single phase, and here we call them as a two-phase molds. We would be getting the components on both the sides. So this is 32 cavity mold, and with in-mold closing on the same. So the component, this is the component what we have supplied, and it is having a tamper-evident cap as well. So it can be closed within the mold, and component is ready to bottle fix in on the bottle. There is no secondary operation required for these components. And this is about the rotary mold. So these molds will need a rotary table, which is an additional attachment which has to be fixed on a moving platen of the injection molding machine. So whatever you are seeing on the screen with a teethed surface, this we call it as a rotary table, which has to be fixed on the injection molding machine. It's an additional attachment or accessories. And these molds will have two different cavity halves. At stage 1, the first color would be filled, and at stage 2, the second color will be filled after the core half has got rotated by 180 degree. And at stage 2, again, when the component has been placed with first stage, the component will get ejected and ready to fill the first color. And this is also the high-end production required molds. It's a cube with 4 stations of cavity or core halves. So the center area is being fixed with a onto a cube which is fixed into the injection molding machine. So we have 4 stations of it. In station 1, we would be filling the first color. Station 2, the first color gets cooled. And station 3, again, we would be pushing a plastic material with different color. And at stage 4, the component is getting ejected. So that's all from my side. Thank you for giving this opportunity for us to present this plastic related molds.
Yeah, thank you, Andy. Thank you for the presentation of all the details, the detailed coverage of the design techniques and the advanced software that is being used in mold making.
Yep.
So we'll move on to the next panelist. Paul Ritik is going to speak.
Yeah.
All right. Yeah.
Good afternoon, everyone. Good afternoon, sirs. I'm thankful to all the team of IEI for giving us this opportunity and to share our knowledge in the advancement of design and manufacturing of plastic injection molds. And yeah, let me share my screen. Let me know if everybody can hear me and see my screen.
Yeah, we are seeing
Yeah.
Vasantha, 32 years of pressure mold making. Is it the screen? Yes.
Yes. We are able to see that, but only thing is that many questions are coming in the question and answers that the video is not being played properly. Please try to that video also played, then it will be more, people will be very easily understanding that.
Okay, yes. Yeah.
Sir, there is also one simple question from Rajendra Krishna Prasad Garu. What is turnover of Vasantha, including global operations? Maybe I think turnover anyone can give.
Yeah, the turnover of Vasantha is around 400 crores.
Okay. Including global.
Yeah, including global and plastic production as well.
Okay. Thank you.
So let's continue.
Yeah.
We have seen advancement in design till now. Let's move on to the manufacturing. So once a good design or a great design is done, after that comes the manufacturing stage, wherein we convert the design into a physical part. Once the design is released for the shop floor for manufacturing, based on the drawing, we manufacture it depending upon the sizes, whether it be round or square, depending on the drawing, we manufacture it. Yeah. So the general procedure for manufacturing a mold, a complete mold, is like, after the design is any mold consists of so many parts, maybe around 50 to 200, 300 parts, depending upon the size, cavitation, and complexity of the mold. So to manufacture all the parts and assemble, the procedure which we follow, once the design is done, all the drawings are released for manufacturing to the planning department, and the planning department segregates all the drawings and process it for further manufacturing. Generally, all the drawings are divided into 3 categories. One is inserts, second is in-house, and the third is mold base. Inserts are the parts that form the plastic component area, wherein the plastic actually comes in contact with the insert. And then comes the accessory parts like unscrewing mechanism or bi-injection mechanism or the in-mold closing IMC mechanism. So all these are the accessories, we call it as in-house items, that are produced, which are not inserts, but they are accessories which help the mold function. Then comes the mold base part, wherein large plates are manufactured in which all these accessories and inserts are fitted. So the general procedure is like, by taking the drawings, they procure the material in which the drawing material is mentioned, which material needs to be used for,
Slides are not moving. You are not
Yeah,
able to.
I'm talking about the first slide, manufacturing procedure of plastic injection molds. Yeah. So the first point is we procure the raw material, and based on the shape or the size that is given in the drawing, whether it be square, cylindrical or flat. So based on that, we do the block up machining. If it's a flat job, it will be rectangular or square. We do block up machining for that. And then we do surface grinding or cylindrical grinding based on the shape, keeping a 0.4 mm stop and having a clean cut. This is to get the zero reference for the block or the cylindrical job at the center. So once this block up machining is done and the surface grinding operations are done, then the conventional milling is carried out. In the conventional milling, we do, especially for the inserts, the cooling holes are drilled, the tapping is done, and because this cannot be done after heat treatment. So all these operations which are possible are done before heat treatment when the insert is still in the soft condition. After this cooling holes and tapping, CNC milling is done on the inserts. After CNC milling, then the inserts are put into heat treatment. We have in-house vacuum heat treatment plant in which we do the heat treatment, that is hardening of the inserts. So once the heat treatment is done, again the inserts are taken out and then surface grinding is done to remove any unwanted distortion in the inserts, and then surface grinding, then the CNC milling, we can call it as hard milling, is done. And after that, the final operations are generally EDM and wire EDM, which we actually see on the part. So these operations are done, and after this, if there is a glossy finish requirement of the plastic part, then polishing is done using diamond paste, or we have a separate department for the polishing. Then polishing is generally done on the cavity side inserts, which we aesthetically see on the part, the outside surface. So after this, after polishing is done, in few cases, we again need to do EDM or CNC milling based on the cut bearing areas where the two inserts shut off against each other. Then once all these operations, manufacturing operations are done, then the inserts move to quality check. And if everything is okay, it is then moved to the mold assembly. If there is something wrong in the insert manufacturing and the quality guy checks it, then it either goes for rework or it gets rejected and we need to make new, depending upon steel and no steel condition. Once everything is okay, it goes to the assembly to the mold maker, and then the mold maker assembles all the parts related to that mold, and then it is given for mold trial. So this was the manufacturing procedure for the mold. Now coming to the inserts building, after the design is done, we need to select the right material for the right inserts. Like cavity sides, we have some inserts, and core side, we have some inserts. Cavity side is responsible for the outer aesthetic parts of the component, and core side is related to the inside surface of the product that we are going to produce, the plastic product. So, and the material, the selection of the material for the inserts also depends on the quantity of plastic parts to be produced. If the quantity is very less, we can use normal pre-hardened steel like P20. But if the production is bulk in few millions, then we have to go with hard inserts like Stevax, Mirax, Orvar Supreme, Unimax, S7, Moldmax. So every material has its importance. Like if we need a glossy surface finish, we go with Stevax and Mirax, generally used for cavity side inserts. And if we have some moving elements which needs nitriding, then we go with Orvar Supreme, generally called as OS. And if we need high hardness, then we go with Unimax material. And if there is a requirement of spring steel, we go with S7. And wherever we need high conductive materials, we go with mold max material, that is beryllium copper, or Rovalma fast cool 50. So all these are insert materials. Coming to the mold based plates, we go with Ramax, that is stainless steel, or P20 or CU45.
Okay, at this point, there are 2 or 3 questions from the audience. I just read out.
Okay.
Maybe our DGM sir and yourself may go through this. One Mr. Commander, Dr. Bhaskar Bhandarkar, Chairman MRDB, is asking, good insight into injection molding process. What are the available technologies to reduce the shrinkage? This is the one question.
Okay.
Another one, once again, by Rajendra Krishna Prasad. Why we are unable to play the video in presentation? Yeah, particularly when you share screen, there is an option that you need to select. When you select that, automatically this will play. So I suggest the presenters that when you share, select not just the presentation, you select the entire thing. Sometimes the screen you may select, or sometimes what we call as the basic and advanced are there. You select the advanced. Then if advanced is selected, and when you start playing PPT, it will automatically play the video also. Whenever video comes, both audio and video will come. This is a usual practice for us. Okay, don't select the basic. The advanced one you can select.
Yeah, we have few videos in this presentation as well. Once we go to that slide, if the video is not playing, we'll switch over to the other advanced thing. I guess in this we'll definitely be able to play the videos, but let's see. Yeah.
Okay.
And regarding the reduction of shrinkage, just now we have seen that there are softwares like Moldex 3D in which we do mold flow analysis, and in that analysis we have basically four major categories, that is filling, packing, cooling, and warpage. So in the warpage area, we can see the part shrinking on one side or the other. Based on that results, we analyze the data, and depending on the shrinkage, to bring it to nominal, we try to compensate the steel in order to achieve the desired part and the desired dimension in the mold. Hope I have answered the question. Yeah. So can we continue?
Yeah, please.
Yeah. So regarding the Stravax and Mirax, so you can see on the right side there is an image wherein in this particular material which is used on the cavity side, which forms the outer aesthetic part of the mold, we can get high mirror or high glossy finish. We can even see our face in it. So the properties of this material is like good corrosion resistance, excellent polishability, good wear resistance, good machinability, and good dimensional stability during heat treatment. So Orvar Supreme is the material which we use generally for the core side of the mold, which has good machinability, excellent through hardening properties, good high temperature strength, that is high hot hardness, excellent toughness, high level of resistance to thermal shock and thermal fatigue, good dimensional stability during hardening. Unimax is the material where we use generally for good thermal fatigue resistance and good wear resistance. It also has good dimensional stability at heat treatment. So S7 is the material, is a spring steel material we use for shock resistance, generally used for sprung cores and lifters, where spring steel is of great help. Then for high conductive materials like beryllium copper and Rovalma fast cool 50, these are used where we need to extract heat faster and reduce the mold cycle time. So after selecting the right material for the inserts, then we need to process it for the manufacturing to give it a physical shape. So to give it a physical shape, we need to have high-end machinery, which will help us bring the drawing into existence, that is the physical inserts. So generally any tool room majorly focuses on three things, that is on-time delivery, quality of the mold, and life of the mold. All this depends on the type of machinery which we use for manufacturing the mold parts. Generally, it should be high-end machinery with high level of accuracies. So we have many CNC milling machines, EDM machines, wire cut machines, then thread grinding, profile grinding, surface grinding, cylindrical grinding, and 3D printing machine, that is EOS. So let's see one by one by playing some videos. Can everybody see this video?
Yeah, we are seeing.
Okay, yeah.
But
We are able to-
audio is not there.
Yeah, there's no audio for this.
Okay.
Yeah. So this is the deep hole gun drilling machine, in which we can drill up to 730 meters length drills with an accuracy of 0.1 deflection. So in total, it is like 1.5 meters, half meter one side and half meter the other side. It can also do the milling operations, and it also has the multi-spindle functionality. Let's see the video. It is 50 seconds or so. So this is the mold base plate, wherein we are going to drill a hole around 500 to 700 mm long or deep. Yeah. So there is one more video for high speed milling. High speed milling, this is for F8 Makino machine, which has a bed size of 800 by 1300 mm with an accuracy of around 5 microns with a spindle speed of around 12,000 RPM. Generally used for mold-based manufacturing. So we have next one more high speed milling machine from Japan, which is imported from Japan, Yazda. The bed size is around 900 to 1500 millimeters with a spindle speed of around 24,000 RPM. We have very good accuracies in this, even less than 5 microns. So next is the video for jig grinding machine. This is in this machine we generally drill small holes and which needs to be very precise, like the gate diameters for wall pins and all. The minimum hole that we jig grind is 1 millimeters, and we make all the H7 holes in this, and the RPM for this is 1,20,000 to 1,60,000 So it is very accurate and precise. So all the gate holes are done in this machine. So as our MD sir Shri Dayanand Reddy Garu has said, we have two robotic cells. One we use for milling operations, and the other one we use for EDM operations. So this one which I'm showing now is for the milling, the robotic cell, wherein the robot does all the operation like picking of the raw material, placing it on the milling machines, and taking the zero and all. I'll just explain once this video starts. On the center, we have the robot which picks and places the raw material on the machine and off the machine and on the CMM. So these are the inserts that this operator is carrying to the machine. These inserts are fed to the robotic placement cell. The robot picks this based on the command given from the CMM machine. So this is the robot, the center robot. So this CMM machine is connected to the robot. The robot, the center zero of the block is taken care by this CMM machine. So the chances of getting error, which we generally do manually, the zero center for any block in the conventional method is taken by the operator, is eliminated because CMM machine takes the zero. However, the workpiece, we need not fix it in a desired position. However we fix it, the CMM machine takes the correct position of the raw material and process it for further operations. So that was the magazine of the milling machine which is connected to the RoboCell. So the zero for the CMM machine, the robot and the milling machine, all three are same. So the chances of getting error is next to zero. And the spindle speed for this machines is 45,000 RPM. So this was all about the milling robo cell for the milling operations. We have one more robotic cell in which we do the EDM operations. This is for the EDM. Generally, these electrodes are made up of graphite and copper, depending on the requirement. The graphite wear out faster, but are used wherever we need sharp edges. So we use graphite. Mostly we use graphite, and then copper has less wear and is also expensive. But few serrations and all we generally see on the component can be done only using copper electrodes. So these are picked by the robot and placed on the EDM machines connected to this cell, and the EDM operation is done. Sorry. So once the operation is completed, it is moved to the CMM machine to check for the accuracies. So once all the operations are done, it is taken to a cleaning chamber where it is sprayed with the oil to remove all the burrs or the dust or the carbon, and then moved to the CMM for the final inspection. It is cleaned here. So no manual intervention. So the major advantage of this robotic cell is like we need less manpower, like four or five machines are connected to this cell, and with just 1 or 2 operators, we can run all the 4 or 5 machines. It reduces rework. We get it right for the first time, and no manual intervention, increased output, and this can even work on holidays. Like we can give the command and go. Maybe it runs for 1 day, 2 days, no problem. Without any errors, it runs consistently and well. So without any operator also it can run once we give the program or the command to the robot. Yeah. So that was all about milling and the EDM and the RoboCell. So this is the manual EDM machine from Sodic, and we have wire cut EDM machine also from Sodic, wherein the final operations of the inserts are done like this. The electrodes are plunged using a dielectric medium, wherein two opposite polarities current is passed through two opposite polarities, and the material is removed to get the desired shape. Which is not possible using conventional milling or any other method. Yeah. So the next latest technology which we have is of conformal cooling using laser sintering. So the conformal cooling technology makes use of cooling lines in an injection mold that curve and closely follow the geometry of the part to be produced. The injection molding, the cooling time of a finished product can constitute up to 70% of the cycle time in series production. Like if the mold cycle time is say 15 seconds, sometimes 10 seconds is the cooling time. So if we are able to reduce the cooling time, then we can greatly reduce the overall cycle time of the mold. Conformal cooling channels in molds and mold inserts optimizes heat dissipation and enables shorter cycle times and plastic product quality. So using conformal cooling, we can go closer to the plastic part, which extracts heat faster and reduces the overall cycle time. Conformal cooling is also a tool to help decrease rejects, because this technology, we don't machine anything. We build the insert layer by layer, that is additive manufacturing. We also called it as additive manufacturing using powder technology, which is burned using a laser. We can see it in the next video which we have. Because of the uniform part cooling, molded in stress can be reduced, and this produces a stronger warpage free part, increases part safety, mitigating part failure and recall risk. So the risk of rejection is very less when we use conformal cooling technology. So generally the designer always worry about how the cooling lines can be taken as close as possible to the part forming area, because in conventional method we can only drill straight holes or angle holes, but we cannot follow the geometry of the part, the complicated parts, I can say. So using the conformal cooling technology, we can follow whatever shape we have of the part, we can follow the same. We have few examples in the next slides. We'll see them.
Yeah, Mr.
Yes.
Ritvik, there is one question. What is the depth the deep hole drilling can make in the die? What is the model and make of such a machine? Can you please give that information?
Yes.
One of the attendees is asking that.
Yeah.
Yeah, I mean, at any point you can cover this. There is no hurry.
Yeah, no problem.
And
Once I finish.
Yeah. We also have one important attendee from Bangalore, Dr. N.T. Rangareddy Garu, who has joined us.
Yeah.
Sir, namaste, sir. How are you doing?
Very fine, sir. Thank you. It is. Thank you, sir.
Okay, sir.
The production engineering division both.
Sir.
Yeah.
Yes.
Yeah, I'll answer all the questions. Once I finish my presentation, it is hardly 5 minutes now.
Yeah.
After that, I'll answer all the questions. Yeah.
Okay, please.
Yeah.
Please.
So the conformal cooling channels built by direct metal laser sintering process reduces overall cycle time of around by 10 to 40%, depending upon the part and the geometry and the type of conformal cooling. Like if the part is very small, the cycle time reduces like from 12 to 10, depending on the part. And due to improved efficiency of the cooling phase of injection molding cycle, the productivity increases maybe up to 60%, 50%, again depends on the part geometry. So the main advantages of the conformal cooling technology is like reduced cycle time and improved product quality, drastic reduction in rejects, like rejection of inserts is minimal or next to nothing, and which directly saves the production costs, improves overall efficiency of the tool and its performance, and also the profits. So we have done a case study in which we have seen the mold function without the conformal cooling and mold function with conformal cooling. So when we have studied it without conformal cooling, it takes almost 50% of the mold cycle time just for cooling the part. And when we apply the conformal cooling technology there, it reduces from 50 to 25. So we have a saving of 25% when we use the conformal cooling technology. So these are few examples wherein it is shown the core inserts where we have drilled. These straight lines can definitely be drilled using the conventional drilling method, but this curved shape which forms the geometry of the insert, thereby of the component, the plastic part to be produced, this is only possible using the additive manufacturing, that is conformal cooling technology. So these are the few examples. So here also you can see these inserts are for the spray cap. Generally we use at homes spray cap or heat caps. So this is the core insert. On the left hand side we can see straight drills. So this is the conventional method, which is only possible in the conventional method. This is the best that can be done, either straight or the angle holes. But on the right side, if we see, that is the core insert with conformal cooling technology. We can drill anything inside the core and that can be printed, 3D printed. So this is the machine, EOS machine, which we are talking about, which help us optimize the cycle time and improve the product quality. So there is a small video of the EOS machine, how it functions, and it uses the powder technology The powder size, the grain size of the powder is generally 20 microns, and it builds layer by layer. Every layer will be about 40 microns, which will be shooted by a laser, which burns only the area of the insert, and wherever there is no insert or like cooling areas, it won't burn. So we'll have a hollow space there. So this is the powder, wherein through laser, we are burning the powder to make it solid. And you can see it leaves some spaces in between, which is the cooling channels. Again, one layer is sprayed on it. Again, the laser starts building it. These are few examples. So this was all about the, this we have seen already in the design. So wherein we had 22-second cycle time using conventional method cooling, then we could reduce it to 17 seconds. This was the part produced. That was a 16 cavity mold, 2x8 layout, which we can see on the left side of the screen. So we can see the cooling time from 12 seconds, we were able to reduce it to 6 seconds. So after manufacturing all the inserts, then we need to think about the life of the insert. So to enhance the life of the inserts, we do two operations. Generally hardening, there is a hardening process and the coating process. So all the part forming inserts and some of the accessory parts of the molds call for hardening process to achieve approximately 48 to 52 HRC Rockwell hardness. Some of the parts having close clearances and shutoffs need to be nitrided to have a hard surface for anti-friction properties, like the sliding elements or the moving parts in the mold generally wear out soon. So we do nitriding for it, which forms a smooth layer on it, smooth hard layer on it to avoid, which enhances the properties of the insert for anti-friction. The hardening process is done using a vacuum heat treatment plant, which we have seen in the video by our MD Shri Dayanand Reddy Garu. Vacuum hardening process is widely recommended for hardening of inserts due to its very low distortion, uniform hardness, and low oxidation. So after this hardening, there are some coatings that we can adopt in the mold parts, like tin coating, CRM coating, DLC coating, hard carbon coating. This is the vacuum heat treatment plant wherein the heat treatment is done. We have it in-house. This is the tin coating, generally used for stripper inserts. Tin coating is a titanium nitride coating. Generally, the advantage of this is like anti-rust and wear resistance. So this is generally gold color. After this, this is the core insert with CRN coating. CRN is chromium nitride coating. We can see it in silver form. The advantages are like wear resistant, rust prevention, and mainly ease of ejection, mostly done on core inserts, core side inserts, where we need the ejection of the part. After this comes the DLC coating. So this reduces the friction and gives the anti-seizing property for the inserts. This is generally done for the moving elements like sleeves. Then we have hard carbon coating for beryllium copper. And this is flash chrome plating, generally used for mold-based materials made up of P20 and C45. Stainless steel does not require flash chrome plating. So this was all about the manufacturing. Lastly, I would like to show one more video of a stack mold, which is a high technology stack mold and a robo pickup. We were not able to see it in the design stage. So let me play it here. This was the 8+8 cavity mold using a robo pickup stack mold. So this is a stack mold which we were talking about. Like we have two places where the plastic material gets injected. Instead of getting only 8 components in one machine, we can produce 8+8, 16 components in one shot. The only thing is the mold thickness increases. Now the weight of this mold was around 13 tons and the tonnage required for this is around 800. So this is the 800-ton machine net style which we have. And once the robo picks the parts from the mold and places it, the robotic arm brings it out. We have outside IMC which closes this flip. It closes the flip and puts it on the conveyor belt. So you can see the cycle time is very aggressive. That is 7.5 seconds. Yeah, thank you all.
Yeah, there are a few questions.
Yeah.
Can I read on behalf of the audience?
Yes.
What is the depth the deep hole drilling can make in the die? What is the model and make of the machine?
Okay. Yeah, the maximum depth of the drill that can be made in the deep hole gun drilling machine is 725 millimeters.
Okay.
From one side. On the other side, same. So it is 1.5 meters.
Nearly 1.5.
Overall bed size.
Overall size. Okay. Okay. Overall depth. Okay. What is that machine on which this can be done?
Yeah.
Deep hole drilling machine. What is the model and the make? Okay. No, if it is a general information, you can give. If you, if it is a classified information, we don't insist. And the next question is,
Yeah.
Ritu, can I ask? Yeah, what DLC coating means?
DLC is diamond-like coating. DLC, diamond-like coating. Yeah.
Okay.
Yes.
And there is an appreciation from one of the participants. Excellent presentation by faculty in terms of content of PPT, style of communication, duly supplementing slides with audio-visual screenshots of manufacturing and industrial process.
Thank you.
Okay, that is. And what is the optimization to be considered in producing plastic components production? Cycle time, machine capacity, number of vanities, stack die set, etc., or how it will affect on cost of component?
Yeah.
How do you achieve the optimization?
Yeah, major focus should be on the mold cycle time. Even if we save 1 second of cycle time, we may gain crores of rupees. That is one aspect, like reducing the cycle time using high-end technologies like laser cusing, that is conformal cooling. The other thing is reduction of the plastic material. So even if we are able to save 0.2, 0.3 grams of the component, that is for huge production, we can save tons of plastic. So that is again lakhs and crores of rupees saving in terms of saving plastic. These are the two major areas where we can save.
Okay. Before we proceed to the next panelist, Dr. N.T. Rangareddy Garu, Chairman, Mechanical Division Board, IEI. Sir, would you like to say a few words on the occasion?
Good evening to Dr. Chandramohan Reddy sir for giving an opportunity to interact. So this is one of the, I can say, as a tooling person, and my Guruji Satyanarayan sir was he was the director of a CITD. I am a product of CITD in 1984-86 batch. So as a tooling man, and the subject is very interesting, and I am very sure that the injection molding tooling engineers will get benefited a lot of this. And I would like to appreciate the initiation taken by Telangana State Center Chairman, and especially my Guru, Dr. Satyanarayan sir, for taking this very interesting, very deep technology subject a full day. Yes. My compliments, and I am very sure that the participants are benefited with the knowledge given by Vasantha Tooltech. And I know personally the MD of Vasantha Tool Crafts Limited. We were almost same time colleagues in the post-graduation. I am from CITD, he was from Delhi Tool Room and Training Center. Thanks. I would like to convey thanks to organizers, especially Vasantha Tool Crafts, for sharing their lot of classified information, which I feel they have come back and shared with all the tooling technologies. Thank you very much.
In a way, Dayananda Reddy Garu was brought in by, I think, Dr. Satyanarayan Garu.
Yes, sir. Yes,
in fact.
So I said all
of course, Brahma Reddy Garu is always there to say yes whenever such proposals come. Yeah. Sir, shall we proceed to the next important speaker, Suresh Kumar Garu, DGM, Design and Development, Vasantha Tool Crafts Limited.
Yeah, thank you, sir. Chandramohan Reddy Garu, thank you.
Sir.
Am I audible to you, sir?
Yes, sir. You are audible, sir. Very much.
Yeah, I'm very glad to meet you. I am 86 batch out from KITS Warangal.
It's Warangal, okay.
Yeah. So, and Mr. Dayananda Reddy, sir, is my guide, mentor, and everything. Of course.
Madhusudan Reddy Garu, DMRL director, KITS Warangal. ఇప్పుడు సిబిఐటి ప్రిన్సిపల్ రవీంద్ర రెడ్డి కిడ్స్ వరంగల్ ఆయన 87 బ్యాచ్.
రవీంద్ర రెడ్డి, in fact రవీంద్ర రెడ్డి and myself we worked together in kids Ramtech in Maharashtra for a couple of years.
నేను ఒకసారి వచ్చాను సార్ రవీంద్ర రెడ్డి గారు అక్కడ ఉన్నప్పుడు. I visited.
Then I definitely I would have met you, sir.
91 లో వచ్చాను. 91.
Yeah, I was there with him for a couple of years. Then I went to Delhi to join this post graduation in tool design and manufacturing. So then after that, my journey into the tool and tool making, tool design has started, sir.
Yes, sir.
Okay, I'll start my presentation, sir.
Yes, sir.
Yeah, first of all, let me thank organizing committee of IEI, and I'm thankful to the entire team of IEA and my management for giving me opportunity to present one second. Sir, you are able to see my screen, sir?
Yeah, we are able to see that.
Sir, everybody is able to see my screen?
Yeah, it's visible, sir. It is visible. Please go ahead.
Yes, sir. Welcome to the presentation of quality systems in die mold industry. Yeah, quality is the most important factor of aspect of our life and every engineering industry. See, quality doesn't come on its own. So quality is the result of continuous efforts and great teamwork. If there is no quality, and I say there is no business, and no quality conscious, please shut down the shutters. So this is how the quality works. The quality has to be there in every organization, in every type of industry. Maybe it be a tool and die making industry, or it may be a textile industry, or automotive industry, or any pharma industry. Whatever the kind of industry it may be, the quality is the most important factor that decides the future of the industry and its runnability and its standby capability to stand in the market. So now what I'm going to dwell on the subject is that quality systems in die mold industry. As I said, the quality is very essential in every industry, and the same is applicable for mold manufacturing industry as well. The quality systems should be designed and established suitable for a modern tool rooms like Vasantha. Different industries will have different quality systems, and those quality systems should be designed and established to meet the requirements of their product and the customers' expectations. I would like to explain about the quality assurance team functions and the responsibilities. The quality assurance does the inspection of raw material and standard parts and inspection of mold parts under manufacturing. There are two kinds of inspection process for the parts which are under manufacturing, like process inspection and first piece inspection. I'm going to explain in detail about each and every point in my further slides. Of course, the final inspection of all the parts and inspection of other parameters like hardness and coatings. Then the quality assurance department also does the inspection of plastic components after mold trials are over. Then we do the process capability studies on the plastic components. Then control of non-conformity products in the steel parts. And we do mold qualification. It is a combined activity of project management department and processing team and QA teams. And we do have a robust process that is to handle the customer complaints and resolutions. I want to explain further what exactly is done on each and every point that I have explained just now. The very first thing is the inspection of incoming raw materials and standard parts. As for the bill of materials, for each and every mold, we'll have a number of inserts and accessories and mold base. Mold base is the body of the mold, where we'll have a number of plates. For all this, we will be procuring raw material from different suppliers. We are importing the material from Europe mostly, and there are so many standard parts which are supplied by outside vendors, and all these parts have to be inspected by quality department, and we have a robust quality plan. A quality plan has been made for each category of material and for each category of standard parts, and what are the parameters to be inspected on these parts are clearly jotted down, and a document has been made, and with reference to that, the quality department will measure and inspect, and they will do the acceptance or rejection activity. In case if a rejection is done, that will be sent back to the suppliers, and a proper action will be taken over that. Then the second most important part or action activity that the QA department does is that inspection of the molded parts, mold parts, that is inserts under manufacturing. That means when I say under manufacturing, many inserts, that means suppose the injection mold is 16 cavity or 32 cavity or 64 cavity. So there will be cavity inserts, core inserts, then again some more stripper inserts. There are a number of inserts. Each mold will have nearly about 6 to 7 types of inserts. Okay, and that is a 32 cavity mold. So 32 cavity into this 6 type of inserts. So that all these inserts, whenever the manufacturing process is going on, at each stage, the quality assurance department has to inspect at every stage. So that is called process inspection. As the inserts are manufacturing is going on, at every process, the inspection has to be done. Again, the another important is the first piece inspection. So what is the meaning of first piece inspection? As you have seen in earlier videos, when an EDM operation is going on, there are certain pallets. On each pallet, sometimes we are keeping 6, depending upon the size. Sometimes 8 inserts we are keeping at one time, and this pallet is going to the mission, and the machining operation is being done, whether it is a EDM or CNC milling, whatever it is. After that operation is completed, the first piece, once it is completed, the first piece machining is completed, that particular first piece has to be taken out and offered to the QA department for inspection. And then the QA department does the inspection of all the parameters and what are the operations done on that first piece, and they have to ensure, they have to accept it. Then only the rest of the inserts will be processed for the operation, because this activity is done only to ensure that the mission parameters and mission settings are done properly and so suitable for that particular operation. There is no point in doing the inspection after all the parts are completed, all the machining on all the inserts are completed, and doing inspection that time. So we have a robust procedure to have this first piece inspection and ensuring that yes, this piece is correct, and you can go ahead for the rest of the machining. So that is the activity done by QA department, and the operations done on certain parts at vendor places also. We are offloading certain operations like thread grinding and profile grinding. At the moment, we don't have those facilities. At the when we receive the when we send the lots to the vendor place, they also do the same thing. They do the machining operation, the thread grinding operation or profile grinding operation on one piece, and they do the proper setting and all that. Then they offer to our quality department, and the quality department will check and inspect that particular piece, and they will give the approval to go ahead with the rest of the batch of that particular tool. So this is also done, and this is a practice that we do for all the inserts of wherever the vendored out. Then final inspection of the inserts and accessories and mold based plates also done by QA department. And the inspection of other parameters like hardness coating, hardness and coating requirements as per the drawings are checked and passed by QA department. Then the other thing is the control of non-conformity products. what is the meaning of non-conformity products? When I say non-conformity products, these are the inserts or the parts of the mold which are rejected because of various reasons. So the QA department will have to identify those non-conformity products, and we have to analyze that and what are the problems that are reasons for rejection and rework. And we have a system called CAPA, that is corrective action and preventive action. These non-conformity products will be segregated and quarantined, and a proper action will be taken, and with corrective action and preventive action. So what is the corrective action is an action to eliminate the cause of non-conformity to avoid recurrence. But it is something like giving an immediate solution so that the problem will not be repeated. Whereas the preventive action is to eliminate the cause of potential non-conformity. This is a permanent solution to avoid any possible or potential non-conformity that would be caused. So these are the activities the QA department will be carried out on all non-conformity products. And this is the what all I have explained is related to the inspection of steel parts or steel inserts and accessories and mold-based parts. Now coming to the plastic parts inspection, after the trials of the molds are completed, we have to do the inspection of the parts, because the plastic parts also will be having engineering drawings which are supplied by customer, and the parts that are produced out of this molds should qualify the engineering drawing specifications. Like and how do we do that? That is there is a system called, we do the SIM process. That is, during SIM process, optimum process parameters are set for a good molding, function, and quality product. See, the SIM process ensures that the process is stabilized and will have a process capability. So normally the SIM process, we do the process parameters set, and whenever the mold is loaded, because mold is normally loaded at least 2 or 3 times, because the first trial, we call it as T0. For a T0 trial, we will have components produced, but that will be seen only whether the mold is functioning properly or not. Are there any difficulties? Are there any functional issues of the mold? After the SIM process is done, the first T1 trials, we will take the components for inspection. That means the process is being stabilized, because there are so many parameters on the molding machine to set the process. Because for a good plastic components to produce, not only the mold should be good, the injection molding machine also should be good, and there are accessories which are associated with the injection molding machine also should be good, and the parameters have to be set properly in such a way that the mold functions well, and the plastic parts that are coming out of the mold are passing to the engineering drawing of the customer. So we do the inspection of the plastic components of the SIM process is established. Then we do CPK reports, because most of the customers, what they expect is that for the critical to function dimensions have to be CPK followed. Then we do the mold qualification when the plastic parts are produced and which are dimensionally okay, and as per the engineering drawing, and fit and functionality test. There are many fit and functionality tests are there which are passed. Then we invite customers to do the mold qualification. Once the mold is qualified, we do the dispatch procedure. And at times we do get some customer complaints. So we have a process of resolving the customer complaints. See, the procedure in Vasantha is that when there is a customer complaint is received, we acknowledge the complaint within 1 day. Then we analyze the problem and find out the root cause within 2 days, and provide a solution to the customer with action plan within a week. Most of the times we follow this concept, and for the delight and for the happiness of the customer. And the QC tool that we normally adopt in Vasantha for root cause analysis is 8D technique. Now, the advances in quality systems in tool and die making, the systems are strong enough, but the advances that have been happened is particularly related to the equipment, the measuring equipment. See, we have very high-end and advanced machines used for measuring of the dimensions and measuring of the geometry of the steel parts as well as the plastic components. So the basic equipment, and not only that, we cannot forget about some of the basic measuring equipments. We also use basic equipments which are named as below. Vernier calipers we use, micrometers, bore gauge, height master, hardness tester, and inspection equipment used while AHT operations and after the AHT operations, and CMM, of course. I will show some of the videos. Coordinate measuring machine, and we have a rapid eye that is it is like a profile projector, but attached to the computer, and inspect for plastic parts inspection. These are the pictures of inspection equipment that we are largely using. See, micrometer, I have shown only one small 0.25 micrometer, but we have micrometers with different sizes, and these are all digimatic micrometers. We can see the digital readings. And with the vernier calipers from Mitutoyo, all these are Mitutoyo, and one is the height master from Trimos. So the vernier also is now what I shown is 0 to 150, but we have different sizes of vernier calipers. And the digital height master, this is the Trimos, where you can measure the heights of the steel parts, and you can measure with an accuracy of 10 microns. And we have other equipments like a roughness tester, because on the steel parts we do sometimes EDM. So EDM will have a different RA values, and as per the engineering drawing specifications, the RA values have to be measured and confirmed by QA for the parts to be assembled into the mold. And we have dial bore gauges, different size of dial bore gauges, and a digital height gauge for checking the heights and dialing purposes. And we have a pin gauge set, as you can see. So these are all small plastic round boxes wherein the pins are stored, so that the pins will not get damaged. They have to be handled very carefully. And this is the we have the pin gauge set from 0.5 to 10 mm steps of sets also. And then we have a slip gauge set. This is a video of the Trimos instrument, how he is using while measuring the heights of a insert. Yeah, what he's doing here is we have a probe which is the horizontal. So there's the probe ball is there. So he will take the reference of this as a datum, as a surface table reference. Then from there he will make it 0, 0. Then come on to this step. Then he will take the reading of this, and he will come on to this step, and he will take the reading here. And there are certain horizontal platforms are there. There are 3 platforms are there. He will take the reading over here, and he will take a reading over here also as well. So from the reference, all these steps will be recorded, and we have so this instrument is connected with a small computer screen kind of thing. All these readings are recorded, and we can take a printout of this. Yeah, that was about digital height master, and we have another equipment called Rapid Eye. So this is an advanced version of profile projector, and this Rapid Eye equipment is going to measure the profiles of the inserts. We have a computer attached to this Rapid Eye, and the measurements are done on the computer, and all the readings are saved, and the printouts can be taken, giving the deviations from the mean. I'll show the video of this. See, there is a slider insert. This is called a slider insert. This is placed on the table of the Rapid Eye machine, and you can see there are the thread teeth are machined. This is done by an EDM process. Now we are checking the accuracy of these thread profiles and using this Rapid Eye machine. And this image of this thread profile on this insert is shown on the computer screen with the magnification of 10 times and 25 times. See, on the screen, you can see the profile of the thread, what is formed on the steel inside. This is magnified to 25 times. And there are cursor lines on the X direction and Y direction. So when we take this cursor and touch the on the edge of this profile, this is going to give the record the dimension. And again, the same cursor is brought to the other edge, and this height will be measured. And similarly, other dimensions are also recorded, and even this entire profile can be recorded onto the computer, and the printout can be taken, and it can be saved as a soft copy as well. See, from the screen, you can see now the distance from the inner edge to this inner edge, this is called thread minor, and the distance from the outer edge to the outer edge is called thread major. So that the engineering drawing will be given clear specification about the thread major and minor, and what are the dimension and what are the tolerances on that. And after having noted or measured these dimensions, then this will be compared with the engineering drawing and specifications. Then it will be accepted or rejected. It will be accepted because the process is done by EDM, and we normally don't have any deviations on this type of jobs which are done on high-end EDM machines. Yeah, this is another very interesting equipment which is called O-Inspect. This O-Inspect is for measurement of dimension plastic components of the mold trials are completed. So this has the facility of measuring by touch probe as well as measuring dimensions by non-touch method by optical sensing method. So where the probe cannot reach, so there are certain plastic components which is having an intricate internal shapes. There we cannot take the probe and take the touch and take dimensions. In which case the optical sensing will be used. There is a feature, the facility is available on this machine that will be used as a method of picking the edges and dimensions by using optical method where the probe cannot be reached. And this is CMM. I think we have in Vasantha about 7 CMMs are there. And this is a universal mission which is called coordinate measuring mission. So most of the dimensions very accurately can be measured using this CMM, and we are using this CMMs for inspection of the inserts after final machining is completed, and also we use this machine hot runner plates, because wherever the requirement is very close and where within 5 to 10 microns, this machine has to be used for particularly very accurate measurements. The CMMs are used. I will show the video of this. So this is the combined video for CMM as well as O-inspect. Sorry. The probe is touching the steel insert and edges are being picked up using this design data from the computer. The programming is done from where and what is the reference and what points needs to be picked as programmed, and accordingly the probe travels and takes the measurements. And this is the mold base which is machined and under inspection. So the dimensions will be taken in all X and Y direction. Yeah. See, this is the measurement of a plastic component on O-inspect. See, there is a picture that is used or made for clamping the plastic component. The plastic component, what we can see is actually transparent. That's why it is also looking transparent color. The plastic component is fixed on an aluminum fixture. Now we are this dimensions of this plastic component are measured by touch method. We have a very small probe, and that can enter into the very inside features, reach the inside features of the plastic component, and you can see the plastic component is fixed to using a fixture. So the dimensions are whatever the maximum dimensions, those can be picked using this probe can be noted down, picked up and measured and recorded. And if there are any dimensions where the probe cannot reach, we'll use the optical method. Yeah, this what I have shown is the video of CMM and O-inspect. Now, the purpose of showing this is this slide is the kind of plastic components what we are making, for which the molds are being made by Vasantha. Now, all these components after the mold has been made, we will go for inspection for the dimensions and also the fit and functionality. Like say some of the components like flip top caps where there is a flip, so that calls for flip opening force and cap removal force. Okay, then sometimes where there is a thread, internal threads are there, then that calls for torque test. Okay, so these are the features that the plastic component should satisfy for the mold qualification. So the photographs what I am showing are some of the equipment that is used on the plastic components, because all the features and all the specifications have to be passed for the mold to be qualified and supplied to customer. Now the instruments what I'm showing here are the surface roughness tester where RJ value can be measured. Now the plastic components will have different sizes and different surface finish on the outer surface of the plastic component, and the surface roughness is clearly mentioned and that needs to be satisfied. Then coming to the torque tester, the torque tester is used where widely the caps having internal threads, and there is a torque specification will be there and that needs to be satisfied, and that within the limits the torque value should be obtained. Otherwise we may have to do some corrections on the plastic component for satisfying the torque requirements. And we have a vacuum leak testing equipment. This is basically to do the testing of any the liquid or whatever the product is there inside the bottle should not leak outside. Like in the supermarkets and all that, we'll see so many shampoo bottles and oil bottles and body lotion bottles. There are many types of bottles, and they're all having caps, and those the liquid or the product, whatever is there inside, should not be leaked out, whatever the condition the bottle is placed. So there is a process of testing the leak. So we put normally colored water inside, okay, so that if the leak happens, we will see that yes, the cap is leaking. So to identify that, we put a colored water and it will be put into the vacuum chamber, so that if there is any leak is there, the fitment is not correct, the product inside, in our case it is a water leaks out, and we can identify that the cap is having some problem on the bottle, or maybe the bottle also could be a problem. So we'll have to identify, we will check and we will investigate and see where the correct action need to be taken, so that this test will be satisfied. And we have a universal testing machine also. Okay, this is a machine normally used for opening force of the flips. Like the right side picture is showing a flip top cap, and all the flip top caps will have a flips, and there will be certain specifications for flip opening force. That means the flip should not be opened very easily, and the flip should not be opened with very high force. So there will be specifications, and those have to be met. So the left-hand side picture is showing the universal testing machine, particularly used for plastic components with low weight specifications. And we have a right side picture that is showing the arm is lifting the flip, and at the point of time where the flip starts opening, then the load will be recorded on the instrument panel. Then the correct values will be recorded and verified with the specifications. And as a systems point of view, these are some of the formats we use in our quality department to ensure that the systems are in place. The very first thing is the inspection report, and this is the format that we use for doing the inspection of the steel components. And whatever the inserts are being measured on the CMM, we get a direct printout from the computer itself, and these are the dimensions which are measured in other equipment. Those are recorded using this format, like serial number, drawing dimensions, including tolerance, and evaluation measurement technique. So what are the instrument that is being used, and what are the actual observations. Suppose if it is a 16 cavity mold, suppose you are measuring a cavity insert, so there will be 16 observations will be here for a given particular parameter. Like if it is a diameter, then here serial number 1, drawing dimension, what is the diameter, or what is the tolerance given on that, and what is the instrument that is being used, and on all 16 cavities, what are the dimensions achieved. Then the QA will have a remark on okay or not okay. So this is the format used for inspection report, making for the steels. And this is the format used for component inspection report. That means after the trials, as I said, we have to measure the dimensions of the component and measure all the parameters as per the engineering drawing even supplied by customer. And we have a rejection slip. So as I told you, the non-conformity products will be there. The rejections could be because of a few reasons, maybe operator mistake, or maybe some mission malfunctioning, or maybe some other issues like a programming mistake, or what manual mistake, or mission mistake, whatever it is. Whenever there is a rejection happened, the rejection will be picked up, and a rejection slip will be raised, and the details will be given in the slip, and they will be informed to the all concerned department heads to resolve that. And finally, we have a mold final qualification, mold final test report. After the mold is assembled, and we have to check whether the mold is now fit and ready for loading onto the mission. Like we have certain parameters that have to be analyzed and that has to be ensured, like parallelism or the fixed off, parallelism of the moving off, parting line, blue matching, because these are all done in the quality assembly of the assembly section, and assembly team will ensure that this is blue matching. That means there are no openings, because the plastic component has a tendency that even if there is a 20 microns gap, the plastic material sweeps out and flashes will come. So we have to ensure that the blue matching is done perfectly. There are no undue gaps, so that the mold functions very well without any flashes. And assembly free movement of the fixed off and the moving off. After the mold is assembled on the bench, we have to ensure that the mold is open and closed, and all the sliders and ejector pins and everything is moving smoothly without any friction and without any obstruction. And the quality department ensures that by using this format, yes, the mold is now ready for loading onto the mission. And we have a non-conformity reports, and whenever, as I told you, there is a method of resolving the issues for non-conformity products. That means the products which are rejected, we have to do corrective action and as well as preventive action. And we will have teams for resolving these issues by corrective and preventive action decisions. And as I explained you, we do the 8D root cause analysis for customer complaints. Normally, the 8D analysis means whenever the customer complaint comes, we do first recognize the problem. So what is the problem? What is the complaint that has been received from a customer? Then we establish the team. Normally, the team consists of design, manufacturing, assembly, and quality. So we'll make a team, and we'll we describe the problem and we contain the problem. Means how the problem is there and what could be the what is the exact problem definition. Then we will brainstorm and find out the root cause analysis. There are certain methods for root cause analysis, like fishbone diagram and YY analysis. So you can see the right side, there's a image of the fishbone diagram to come to a conclusion that the corrective action, preventive action, all these things are necessary to be done by the team. And this is the method of finding out the root cause. Once the root cause is found out, then it is easy to provide a solution and resolve the customer complaint. Once this is done, we select and verify the corrective actions and establish, and horizontal deployment will be done so that the issues will not be raised and will not be coming into the future. Yeah, this is one kind of pie chart we normally do as far as the rejections are concerned. See, if there are some rejections which are amounting to an amount of ₹1 lakh or 50,000 in a month, then our quality department will analyze what are all the departments or the areas and contributing to these rejections. So after having taken the data from the rejections and the root cause analysis is done, we'll sort out from each department what is the percentage of contribution for the rejection, and this pie chart will be discussed in our management meetings, and appropriate actions will be taken. If the operators have to be trained, they will be trained, and if any equipment fault is there, the equipment will be replaced with the new equipment. Of course, and if any design issue is there, design corrections will be done. So all the necessary actions will be taken based on this analysis and the data what the QA department gives to the management. And lastly, as the international accreditations, Vasantha is ISO 9001:2015 certified by TUV SUD, and we have all the robust systems, and we follow the latest version of 2015. We passed the 2015 version in 2018, and we have a robust quality management system in place, and we have been following these systems very meticulously. And other international accreditations are like TS 16949 2016, which is specific to automotive sector. Suppose if any tool and die shop or tool room is catering to automotive sector, then this TS 16949 2016 is mandatory, and this certification has to be there. Otherwise, the automotive sector may not attract and give the orders to this particular tool rooms. And other recommended international accreditations can be EMS, that is Environmental Management System, ISO 14001 in 2015, and OHSMS, Occupational Health and Safety Management System, ISO 45001 in 2018. We don't have this, but now we are working on this, and probably in a year or a couple of years, we are going to get onto these international accreditations as well. So thank you all. My presentation related to the quality systems in the die and mold making ends here, and I welcome any questions in this my presentation.
Thank you, sir. Thank you, Suresh Kumar Garu, for the wonderful presentation on quality issues.
Yes, sir.
There are some questions appearing in the chat box. So I read out them. I mean, once we answer these, then we can invite some more questions from the audience. From where you buy these raw materials? That is one question. One thing, any of the three of the panelists can answer this. If it is a general information, you may give. Classified, we don't insist.
We buy it from Udalum. Generally, we import it.
Okay. Next, electrodes will also be inspected for every operation, right?
Yes, sir.
Okay, right.
The electrodes are equally inspected for all its parameters.
Okay, fine. Next,
Because
generally,
the quality of the insert, steel insert depends upon the quality of the electrode.
okay. Next is generally computer integrated automatic manufacturing will be less in terms of cost compared to manual manufacturing, because the present day, if you take the manual manufacturing, the conventional manufacturing will be more compared to the computer integrated manufacturing. That is what the attendee wants to know. Is it true in your company also?
Yeah, it is true. Computer integrated manufacturing will definitely be costly than the conventional method. But as we are like more than 400 crores company turnover, so we have to do it repeatedly. So this gives us more accuracy and high rate of manufacturing and production.
Okay. That is understood, sir. I mean, of course, what is 8D technique of quality? Of course, that is already explained in the presentation. Next, are you using GD and T? Yeah. Geometry dimensioning and tolerancing in your design and development of manufacturing drawings for plastic injection molds making?
Yes, sir. We are using GD and T, and our more focus is on tolerances.
Yeah.
The drawings that we release for manufacturing will have a tolerances based on the fitment and its function.
Okay.
Yeah, the tolerance, otherwise, there is a robust tolerancing system in the design department itself.
Okay.
Okay, so all the features of all the drawings will be bearing the tolerances.
Okay. See, how is the physical properties of the molded part checked, such as the tensile and percentage of elongation? That is tensile strength. Do you molded part? Certain properties it should have, not exactly the tensile, physical
Yes, sir.
properties.
Yeah.
Such as the tensile strength or compressive strength or percentage of elongation. How do you check?
Sir, actually, I want to explain. See, basically, we do check the customer specific requirements, sir. Like, suppose if there are any caps and closures which are fitted onto the bottle, okay, and the customer will have a specification that when the bottle is filled with their product and the cap is tightened, and when it is dropped from a height of 1.5 meter, the cap should not come out and cap should not break in any direction. Okay, so these kind of specifications will be there. Suppose if the bottle is dropped with a cap fixed in with a product of the customer, then if it is cracking in any direction, the bottle is tilted and dropped, and bottle is put in horizontal and dropped, okay, and bottle is put vertical and the cap is upwards, dropped, then also it is breaking. So then there is a issue. So we have to look into the area where the cap needs to be strengthened. Maybe if it is required to add the plastic, and we do add the plastic and thicken the particular area where the weak section is there, so that the drop test can be passed.
Okay, sir. Understood, sir.
Yeah.
Because the based on the utility and the particular type of
yes,
application of the component, these tests are devised.
Exactly.
Not exactly the physical properties that are meant for the most of the metallic products. They are different, and here the tests are different.
Yeah, exactly, sir. Yes.
Next, there is, of course, one appreciation. Thanks for IA leadership for arranging this webinar, which surely enhanced our knowledge. Also, thanks to Vasantha team for good presentation. Okay, that is about the chat box. And now, specifically, I also invite some questions from the audience. I mean, if they want to ask, they can ask, if it is possible. Otherwise, if they are not in a position to ask, they can type here. I will ask on your behalf. So chat box questions are over, sir. Now it is over. I think before I leave it to others, I have a duty to sum up the presentations here. So we have the very first wonderful presentation by our Dayananda Reddy Garu on just one moment. Just one moment. Yeah, Dayananda Reddy Garu on the topic of overview of plastic dye industry, and he has given certain fundamental coverage of the fundamental aspects, whether it is a one-time used or multiple number of times used component, whether it is biodegradable, and he has also covered the areas of product design, making use of FEM, DFM, and flow analysis. He has also explained about the mold design and the evolution, also how the technology of plastic injection molding evolved over a period of time, and the complete list of the machining technologies and the testing that is to be followed. He has given the complete overview so that anybody can understand at an instant. Then Mr. T. Phanindra, Senior Manager, he has dealt on the topic of design techniques and use of advanced software for mold industry. He has completely dealt with the design and simulation aspects, use of software, advanced system, simulation software, flow analysis software, particularly MoldX 3D, and runner systems, including the fully hot runner. And there are high complicated and high production molds such as stack mold and rotary mold also he has explained in his presentation. And then we have the presentation by Mr. Paul Roth, Ritwik, Assistant Manager. He has covered on the manufacturing and materials and coating of die mold, coatings of die mold. He has clearly given the manufacturing procedure of plastic injection mold, that is the procurement of raw material and machining aspects, surface grinding, and conventional milling. All these complete list of the procedures he has explained, and he has also explained the advances in mold materials, advances in machining, and making use of the robotic cell, and particularly coatings. He has given a detailed presentation. Then when it comes to our DGM, Mr. N. Suresh Kumar Garu, he has given the complete advances with respect to the quality systems in die mold industry, the complete instruments that are used, the advances in instruments he has explained, and the methodologies to be followed to ascertain the quality, whether the requisite quality has been achieved by the product or not. He has given a detailed count. And of course, the formats to be used by the quality department, and also several aspects pertaining to the quality aspects, quality standards he has explained, and quality certifications that they have got, he has explained. So with this in all, the participants are really enriched with these presentations, and from Institution of Engineers, on my own behalf, I would like to congratulate Vasantha Toolcrafts Limited for coming forward and liaising with IEA in organizing this particular program, and also IEA for the initiation, wherein it is really useful to the industry. And with reference to my request, there are two more questions the audience have asked. Functional specifications of plastic components inspection. Functional specifications. Are there any functional specifications? That is one question. And one more question is, how are the shrinkage? How is the shrinkage allowance incorporated in die design? Shrinkage allowance, maybe at the stage of die design only, it has to be taken into account. For metals, we know, maybe for, I believe that they follow the same for the plastics also. Maybe anyway, it is over to the panelists to explain us.
Yeah, for different plastics, we have different shrinkages. Like for PP, we consider 1.7% shrinkage, HDP 2%, LLDP 2.2, ABS 0.5%. So based on the shrinkage, when we are designing using say Creo or NX, there is a particular tool called as tool design set in Creo and mold wizard in NX, wherein we can specify the shrinkage of the plastic material that we are designing. So we apply the shrinkage, and the inserts are made oversized by that person, so that once the molding is done and the plastic is injected, after it cool downs, it comes to the desired dimension which we need. So this is a module in the software wherein we give the shrinkage for the plastic.
Okay, well taken. And functional specifications of plastic components inspection. Functional specifications of plastic components inspection.
Yeah, for every plastic part where there is a fit and functions required between the bottle and the cap, like there would be some leakage or should be there between bottle and the cap. So we call that as a built-in plug where it seals with the container. So there we need some tolerances to avoid the leakage issues. And also, as Suresh sir explained, related to the torque. So it is also a functional test where we need to test the values, to reach the values.
Okay, sir. Thank you. Really, I think, are there any? Yeah, very informative webinar. Congratulations and thanks to organizers. Can we have a presentation or link to recorded presentation? Yeah, it is there, sir. It is there very much. The organizers have already provided that webinar link that they can find in the. It is there.
It is there in the YouTube.
Yes, sir. It is there in the YouTube. And if I can locate that, I'll try to get that and put it in the chat box. I will do that. In the meantime, now it is over to the Institution of Engineers, Telangana State Center, to complete the other aspects.
Thank you, sir. Thank you, Dr. G. Chandramohan Reddy garu, for your excellent summing up of the entire today's seminar. And
Thank you,
really
sir.
is an excellent presentation by all the speakers and the chief guest also. They were very elaborate of the holding, although we are not from that production engineering, but I could really enjoy the all the technical talk by Suresh Kumar garu, all Ritvik ji and Manindra ji. We are really very thankful to you and your MD Sir Dayanand Reddy garu for obliging us and also participating in this seminar. And we look forward such seminars in future also, your participation. I thank you, all of you, sir, for your wonderful and very practical presentations with a lot of content, which is very useful content for the audience. And thank you very much. And you also excellent answering of all the, I think all the participants who have asked the questions, they're all satisfied with your answers as well as your good presentation. And we appreciate you for participating with us and this thing. And I thank Satyanarayana garu for all these efforts of bringing you on the platform of Institution of Engineers India, and also our Dr. G. Chandramohan Reddy garu for excellently doing moderation of this thing. And I also thank Rangareddy garu all the way coming from Bangalore and participating in this, and our commander Dr. Bhaskar Bandarkar garu, and all other council members who are, I can't see on the screen, but I thank them, all of them, for their excellent support and participating in this. Now I request my honorary secretary, Dr. Venkat Subbai garu, to propose vote of thanks. Before his vote of thanks, actually, I felt I should thank. That's why I given my from chairman I have given, but actual vote of thanks will be presented by our honorary secretary. Thank you, sir. Thank you very much.
Thank you, sir. Respected chief guest and keynote speaker, Mr. A. Dayanand Reddy, Managing Director, Vasantha Tools Crafts Private Limited, Dr. H.O. Thakre, FIE, President, EI, Dr. S. Satyanarayana, FIE, Chairman, Production Engineering Division Board, IEI, Dr. G. Ranganath, FIE, Chairman, PATE, IEI, B. Brahma Reddy, FIE, Chairman, IEI, Telangana State Center. Today's webinar moderator, Dr. G. Chandramohan Reddy, FIE, Professor. Speakers, Sri M. Suresh Kumar, DCM, Sri A. Vanindra, Senior Manager, Design and Development, and Sri Paul Ritvik, Assistant Manager, Design and Development, Chairmen of Division Boards, past Presidents, Council Members of IEI, past Chairman, past Honorary Secretaries, Members of Telangana State Center Committee, IEI, corporate members of IEI, distinguished guests, representatives of media, ladies and gentlemen, good evening to all. On behalf of Telangana State Center of IEI, on my own behalf, I convey our sincere and profound thanks to the Mr. A. Dayanand Reddy, Managing Director, Vasantha Tools Crafts Private Limited, for addressing the gathering as chief guest and delivering the keynote lecture. I express my heartfelt gratitude to Dr. H.O. Thakre, FIE President of IEI, and also Dr. G. Ranganath, FIE Chairman, PATE, for addressing the gathering on this event of one-day webinar. I also thank the webinar moderator, Dr. G. Chandramohan Reddy, FIE, Professor CBIT, Hyderabad. I am grateful to the speakers, Sri M. Suresh Kumar, DBM, Design and Development, Sri A. Vanindra, Senior Manager, Design and Development, and Sri Paul Ritvik, Assistant Manager, Design and Development of Vasantha Tools, for their excellent practical lecture. And I am also very happy to know that two members are associated with the Kids Warangal. I was also associated with Kids Warangal as the assistant professor. I worked there in Kids Warangal for 3 years since 1997. So I'm very happy with this movement. I'm grateful. A special thanks to Dr. S. Satyanarayana, Chairman Production Design Board, for giving an opportunity for Telangana State Center to conduct such a wonderful webinar today. I also thank the past presidents of IEI, past chairman of IEI, Telangana State Center, chairman of the engineer Rangareddy Garu, Bhaskar Garu, and other chairman of different boards, secretaries, past honorary secretaries of IEI Telangana State Center, council members, committee members, corporate members, and others who made it convenient attended this webinar. I also thank the representatives of media. Last but not the least, I extend my heartfelt thanks to the King Sukh Sen, Assistant Director Technical Department, for making wonderful arrangements for the successful conduct of this webinar. Thank you, Canada. Now I request all of you kindly stand for national anthem. Mahesh, are you playing? Yes, sir, we will start, sir. Jana Gana Mana Adhinayaka Jaya He Bharat Bhagya Vidhata Punjab Sindhu Gujarat Maratha Dravida Utkala Vanga Vindhya Himachala Yamuna Ganga Chala Jaladhika Ranga Tava Shubha me jage Tava Shubha ashish mage Gahe Tava Jaya Gadha Jana Mangaladayaka Jaya He Bharat Bhagya Vidhata Jaya He Jaya He Jaya He Jaya 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 Jai Hind. Thank you once again to one and all.
Thank you.
Vasantha, thank you very much. Wonderful presentation. I think a lot of classified information also you have made available to all the participants. Thank you very much.
Thank you, sir. Thank you.
Thank you, Andy. Thank you all the team members, and we convey our special thanks to your MD. And of course, Dr. Satyanarayana Garu for the efforts, and Engineer Brahmareddy Garu, Chairman, for making it organized in a very nice fashion. And of course, Venkat Subbai is there. And Dr. N.T. Rangareddy Garu, special thanks for joining by sparing your time from there.
That is definitely what he got, because he's basically a tool engineer.
Suraj Kumar sir, your former colleague Bodhananda Giri is my classmate, sir, in NIT Warangal.
Okay, thank you very much. We'll close this here.
Yes, sir.
Yeah, Giri. Giri is your classmate, sir?
Yes, sir. In NIT Warangal, sir, we did BTech. After that, I joined in Kids Warangal as assistant professor, sir, and served there for 3 years.
Okay, sir. Very glad to meet you, sir.
Yeah, very nice.
Giri called me yesterday. Giri called me yesterday and he told about you, and I think you have sent the link to him and asked him to participate in the today webinar.
Yes, sir. So he participated, sir. Throughout the program, he is there.
Oh, very nice, sir. Very great. Yeah. Thank you so much, sir.
Thank you, sir. See you, sir. I will meet you, sir.
Thank you very much. Yeah.
Thank you, sir. Thank you, one and all.
Thank you. Bye bye.
Okay, sir.
Thank you, sir. We are concluding the webinar, sir.